They want us to get how many people attended the music concert. So all we need to do is just add up all those numbers. Okay. So I'm just gonna add up those numbers very fast. So we say this is 35 is less x less or equal to 45. So I'm gonna add that. So I have a 20 plus a 25 plus a 60 plus a 90 plus a 55 plus a 40 plus a 30. Okay. And the total that I'm ending up with is 320. So these are the number of people that attended that concert. All right, and then 2.3, they want us to draw a cumulative frequency graph. Sometimes we call this the OGI, okay, to represent the data. Okay, so one thing we need to know that as we are plotting the OGI or the OG, we need to know what we plot and what we don't plot. So since the grid just has everything that we need, we have the cumulative frequencies here, and then we have our edges this side. So these edges are more like the classes, but from the information, we don't have the cumulative frequency. So we need to create some sort of a color for the cumulative frequency. Okay? Because the cumulative frequency that we use when we are plotting a cumulative graph, we don't use the frequency. And how does the frequency of the cumulative go about? So the first frequency will represent the first cumulative frequency. And then for me to get the next cumulative, I'll just plus this 20 plus a 25. I'll get a 45. And then 45 plus 60, I'll get 105. And then 105 plus 90, I'm gonna get 195. Then 195 plus 55, I'm gonna get 250. 250 plus 40, I'm gonna get 290. Then 290 plus 30, I'm gonna get a 320. So the last cumulative must always correspond with the total number of participants or your total frequency. So I'm gonna plot 75 with 320, plot 65 with 290, 55 with that, 45 and that, even this 15 must go with the 20. And then I'll just extend my graph to a minimum, okay? So what I'm gonna do, remember we said we have a 20. Let me just put it somewhere. 20, 45, 105. Okay, so we know that the first one is 15, that goes with 20. Just okay, 15 is between 10 and 20, which is like halfway. 15 goes with 20. This is 1, 2, 3, 4, 5, which is 10, 10. So which means it's gonna be somewhere here. Okay, so this is the mark that I have. And then now I go to 25. 25 is gonna go with 45. Let me just make this a bit smaller so that I can see my values nice. So I got 45. So 25 is still in between here. I need a 45. That's a 40. So somewhere in the middle there. No, that's a 40, but it's close, slightly above. Okay. Then I'm going to 35. This is the line of 35. 35, where are you? You're going with 105. 35 with 105, this is 100. So somewhere, okay. And now I need 45. 45 is 195. So just before 200. Slightly before 200. Okay. And then I need 55. We said it's 250. 55 is 250. Just on the line here. Okay, and then we have 290. 265 is 290, just below 300. Okay, and then we have a 320. All right. Then we have a 320 for the last one, which is 75. This is 300, and this must be 320. Okay, so from that, I just need to connect that with your freehand. It might not look like an S curve for now. But remember, it's an algebra, so it has to just that. Okay. And then remember, we said this must be connected to 5 and 0. So the starting point is 3. So just connect that to that. Okay, so that's going to represent my algebra. So this is the 5, which is the starting point of minimum transmitter. All right, that is what we had to do. Then they're asking us to use the graph to determine the median. All right, so with the median, since we have 320 people, some people prefer using a half of n plus 1 to get just the position. So that it is a half of 320 plus 1, and then they locate where that is. Okay. So what is a half of 320? Let me first use this approach. It's gonna give me it's my graph or what, but let me just try to. Let me rejoin this line and see. I'm sorry, guys. It's live. I don't know. Something like that, guys. This must be slightly straight, but somewhere there. So I'm just gonna use a half of n. I can do the same with a half of 320, so it's 0.5 times 320 plus 1. That's gonna give me 160.5. Okay. 160.5 is just the same as 160. So which means I locate 160 on this side. Okay. And then I must follow this line of 160 till I meet up with the graph. So it's where my graph is meeting. And then I'll drop this downwards. Find how many years it is. Okay. So this was 41, 2, 3, 4, 5. So it means every block is representing 2. So that's going to be like 42 years. Okay. So it's saying that's going to be 42 years just from the graph. Then question number 3. Question number 3. Let's make this a little bit smaller. Okay. So with question number 3, we're being told that in the diagram, the equation of AF is y is equal to negative x minus 11. Okay, this is the line AF. B is a point on the x-axis such that this B is a midpoint. The straight line joining A, which is down there. Okay. joining A and C. The angles of inclination are that, and the alpha, so angles of inclination are alpha, and then the 63,43 respectively. AF cuts, where is AF? Okay, it cuts the x-axis at B, and then D is a point such that DE, okay, this line is parallel to AC. And that one parallel. Okay, so that is all the information we have. First question, they want us to get the value of T. So where is T? T is by point A. Okay, but then since we have the equation of the line onto which T is whatever put, we can just substitute this point into the equation of the line, because if the point is lying on the line, that point must satisfy that equation. So we're going to have y is equal to negative x minus 11. What is the x coordinate? The x is negative 1. So I'm going to say y is equal to negative 1 minus 11. The answer is negative 10. Okay. So which means my t is negative 10. Then they want me to get the size of alpha. So for me to get alpha, remember alpha is an angle of inclination. From our earlier grades, we say that if you have m, it must be equal to the tan of, let's say, alpha, but the gradient must be equal to the tan of the angle of inclination. So the question was the value of alpha. So for us to get the angle, we must get the shift tan, the arctan of the gradient. So we need to know what is the gradient of this line. From the equation, y is equal to mx plus c. This is y is equal to negative x minus 11. So our gradient is a negative 1. Okay. So I'm just going to replace that with a negative 1. But since I'm going to end up with a negative answer, because I know that the shift tan of the negative 1 must give me a negative answer, I need to plus 1 so that I end up with a positive answer. Okay. So I'll say shift tan of negative 1 is negative 45. So the negative 45 is just representing this. Negative, but that is a 45 down. And since angles are on a line, angles on a straight line, I must just plus 180 or subtract from 180. And then I get the answer. So that's negative 45 plus 180. And then I get 135 degrees. So that is my alpha. Then 3.1.3, they want the gradient of AC to the nearest whole number. So AC is this line. Okay. But all we know about this line is just one coordinate, which is E. So we don't have any other coordinate points that we have. So we cannot use the normal changing y over changing x. But all we have is the inclination angle. So we're going to say that the gradient must be equal to the tan of the inclination, which is 63,43. Okay. When I use this, I'm getting 1,999,568 and so on. But they told us we must round it off to the nearest number, nearest integer. Okay, so that is a 2. And then we're done. Then 3.2, they're asking us to get now the equation of AC. Now, since we already have the gradient, and there's this one point A, we can use that. So we're going to use the gradient of 2 and point A, which is negative 1 and negative 10. Remember correctly, yes. So there are two ways of doing this. Some people prefer using the mx plus c format, where they substitute the m and these points and get the value of c. So let's see. So where there is x, I'm going to put a -1. Where there is y, I'm going to replace with -10. So -10 is equal to m, which is a 2 times -1 plus a c. Then I'll move this to that side. Okay. So that's going to be -10 plus 2 is equal to c. So my c is -8. And that is done. I'll just rewrite it as 2x minus 8. Okay. Alternatively, someone can use y minus y1 is equal to m into x minus x1. So still the same thing. That is y1 and x1. I'll replace these coordinates. It will be y minus -10 is equal to 2 into x minus -1. This is y plus 10. When I open that, I have 2x plus a 2. Then I'll move the 10 that side. It's going to be 2x plus 2 minus 10. So that y is 2x minus 8. So it's just the same equation, but different formats. So you choose whatever will work for you. And then 3.3.1. Okay. So 3.3.1, they want us to get the coordinates of C. Now, since we have the equation, for us to get the coordinates of C, we need to know the coordinates of B first. Then we can apply our midpoint formula. So what I'm going to do, I need to get the coordinates of B. Okay, so I'm saying the coordinates of B. From my equation, y is equal to 2x minus 8. We know that at B, y is 0. Okay, let's just replace y with a 0 and look for the value of x, since B is on the x-axis. So 0 is equal to 2x minus 8. Can move the 2x that side. -2x is equal to -8. And then I'll divide by -2, so which means my x is a 4. So the coordinates of B are 4 and 0. Then from the midpoint, which I know that x1 plus x2 over 2 must give me the midpoint. Then y1 plus y2 over 2 must give me the y coordinate of the turning pole of the midpoint. So if I call the coordinates of C to be x and y, okay, so I'm going to combine this x and this -1. I combine the two of them so that I can get my 4. The x and this -1 must give me a 4. It's the midpoint. And then this y and the t, which was a -10, combined using the midpoint, and must get to 0. All right. So we say if I get my x plus my -1 over 2, I must end up with a 4. And then I cross multiply with this, so I'm going to have x minus 1 is equal to 8. Then I'll move the 1 that side, x is a 9. Then do the same thing if I have y plus a -10 over 2, must give me a 0. Cross multiply. So y minus 10 is going to be a 0 because 2 times 0 is 0. Then I'll transpose the 10 that side, so which means y is a 10. So the coordinates of C are just 9 and 10. All right, then 3.3.2, they want the size of FED. What is FED? FED. So they want us to find this big angle. This angle. All right, so what I can do, It's a two-way thing. If I call this maybe M, just I know that this angle is 63, for that, even this angle here is going to be 63.43. So if that is 63.43, which makes this angle alone, our bottom also be 63.43. Okay, because they are corresponding angles. Remember, these lines are parallel, so those angles will be corresponding. And then since our alpha was 135, which means this remaining patch is going to be a 45 degrees, and then I can plus the 2. So I'm going to say MED, or if not, I can start with OBA. Okay, I'll start by saying that OBA, okay, OBA is 45 degrees, because those are vertically opposite angles. Okay, and then remember we've created M, so it's going to be MED. So MED is also going to be 45 degrees, because those are corresponding angles. For which lines? DE and AC. DE is parallel to AC. Then I can say that MEF, 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 what am I doing? What am I doing? There's something wrong here. Just have to restart afresh. Not the 45 times. 63.43. 63.43. 63.43. So this is the 45, which will be angles on a straight line. Okay. Then now I can have my FED to be the sum of 45 plus the 63.43. Okay. So that's going to give me 108.43 degrees. Then 3.4. J is a point such that EAGC, EAG, C is a parallelogram. So if EAGC is a parallelogram, which means EG must be a diagonal. Okay. So if I connect this to that, this to that, and to that. Okay. What do they want me to do? Question, what are you asking for? You want the equation of a circle that is centered at G and passing through B. So which means I need to find the coordinates of G. That's what they're indirectly asking for. But one thing we know about a parallelogram is that the diagonals do bisect each other, which means the distance from A to B must be the same distance from B to G. So which means B is still a midpoint. Okay. So what we don't know are the coordinates of E. If we can get the coordinates of E, then we can get the coordinates of G. Okay. So I'm going to say from y is equal to negative x minus 11. We know that at E, y is also 0. So where there is E, I'm going to put a 0 where there is y. Okay. So 0 is equal to negative x minus 11. Move the x that side, which means x is 11. So the coordinates of E, it's a negative, not a positive. The coordinates of E are negative 11 and 0. Then from the midpoint, remember x1 and x2. So I'm going to call this x1 and y1. Then combine it with the coordinates of g, which are -11 and 0. Combine them and must get a 4 and 0. So I'm going to have x plus the -11 over 2 must give me a 4. Okay, I'll cross multiply that. So x minus 11 is 4 times 8. So 4 times 2 is 8. I'll move the 11 that side. I have 8 plus 11, which is a 19. Then do the same thing with the y. So y plus, why should I even stress with y since y is on the same line? Okay, so y is 0. So therefore the coordinates of g are 19 and 0. Okay, it's the same horizontal line. Since P, G must be diagonal, which is the x-axis. Then, since I want the equation of the circle, this distance BG is going to represent my radius. So I need to get the distance of BG, but since it's the same horizontal line, I'm just going to subtract what is 19 minus 4, which makes it 15. So my radius is 19 minus 4, which is 4. So for as long as the distances are either on the x-axis or the y-axis, we don't need to use the distance formula. Just subtract those values. For as long as the y values or the x values are the same, just subtract the big one and the small one. Okay, so from the equation of the circle, y minus a squared plus this must be equal to r squared. So x minus a squared. And so I'll substitute that's going to be x minus 19 squared plus, I know y minus 0 is y, so that's y squared is equal to my radius 15 squared. That's going to be 225. All right, question number 4. Question number 4. Question number 4. Are telling us that in the diagram, the equation of the circle at M with these center coordinates is given as this. And the equation of the center at M is given as that. Okay. Then P, R, and PS are tangents to the circle M. PR is parallel. PR is parallel to the x-axis. And then we have coordinates of K, which is -17 and -5. The straight line N cuts the smaller circle at T, and then the larger circle at S. All right. Then the first question is asking us to write down the coordinates of M. Do we have the equation of circle M? The answer is yes. Because remember that equation is x plus 6 squared, then y plus 3 squared, then 25. So remember what we say, we always just get these coordinates but switch the signs. Okay, so M is going to be -6. -3. -6 and -3. There we go. Then they want us to get the length of the radius of the smaller circle. Now, from the equation, okay, so we have x squared. So say -6 and -3. So from the which is x squared plus y squared 24x plus y squared plus 24x minus 25 it's 10y plus 153 must be equal to 0 plus 24x. Okay, there we go. So for us to get the the radius, we need to complete the squares. Remember what we said. You can do the grouping if you want. The x and the x and the y and the y. So I'm going to say x squared plus the 24x. And then I'm going to have y squared minus the 10y. I'm going to take this side, which is negative 153. And when I complete my squares, symbol said it's x, and then the sign, which is a plus. And then we have this. A half of 24 is 12, and then you square that. So we know that a half of 24 is 12. When you square 12, you're going to get 144. So which means on our right-hand side, we plus the 144. And then we do the same thing with the y. This is y. The sign is negative. A half of 10 is a 5. We know that negative 5 or positive 5 squared must give us a 25. So I'm going to plus the 25 inside. And this is going to be x plus 12 squared plus this is y minus 5 squared is equal to, I simplify my right hand side, I have negative 153 plus 144 plus 25, 16. Now remember, from the general equation of this circle, this is y minus 5 squared is equal to r squared. So this 16 is representing r squared. So we need to find the square root of 16, which means our r is 4 units. Okay, r becomes 4 units. That's from there up to there. All right, that is done. Then the next question is asking for the length TS. So the distance between T and S. All right, so do we know the radius of the big circle? Yes. Okay, so the radius of what is the distance SM? So I'm going to say the distance SM is going to be the square root of 25, which is 5 units. Okay. We say the distance of NT we found it to be 4 units. Then all I need to find is the distance NN. Then I'll subtract these two. So NM from the distance formula, we said x minus x1 squared, and then y minus y1 squared. And I try to substitute that. Remember, I have negative 6, negative 3. And I have negative 12. The square root. I'm going to have negative 12 minus 6 squared plus. It's a 5 minus 3 squared. Can put this in brackets, please. Then when I punch that into my calculator, I'm getting the square root of 36 plus 64. And then that is giving me 10. Okay. So that 10 is representing the total distance from N to M. But we say this is a 5, and then this is a 4. So what is left here? It's going to be 1 unit. So 10 minus 5 minus 4, which is 1 unit. So therefore, ST, is that what we are calling it? Yes. So ST is 1 unit. Then 4.3. 4.3. Determine the equation of the tangent PR. We want the equation of this line. What do we do? Should this be negative? So we know that this line is parallel to the x-axis, and we know that the x-axis is in the form of y is equal to 0. So which means all horizontal lines must be in the form of y is equal to something. But we need to find out how low is point R. Since we say this is 5 units, even that will be 5 units. Already I have the same circle. Yes. So I'll start by saying that my MR is 5 units. Okay. Just the distance from M to R. And for me to get the total distance from the x-axis to R, I'm just going to take this -3 and 5. Okay. So I will say if I have my 5 minus -3, that's going to give me 8 units, which means from here up to R, those are 8 units. They are down. Just like -3 minus 5 must give me -8. -3 minus 5, they're saying -8. So y becomes -8. That is the equation of that tangent. Okay. And then the next question wants us to get PS. Okay, what is PS? The equation of PS in the form of mx plus c. PS in the form of mx plus c. So do we know the gradient? No, we don't know the gradient, but we have one coordinate point, which is fine. We can get a gradient from mn, since it's a straight line, and so I'll start by finding the gradient of mn. Okay. So gradient of mn is going to be change in y over change in x. Okay. Then I'm going to have 5 minus -3, okay, over -12 minus 6. Simplify that, that's going to be 8 over -6. And that's giving me very negative. Yeah? But one thing I know is that this is more like a radius. Let's say MS is a radius. But we know that the radius and the tangent will be perpendicular. So from my M1 times M2 being equal to -1, the condition for perpendicular lines. So if one line is -4/3, I'm just going to flip that and say that the gradient of PS is going to be 3/4 positive. Since it's negative, it must be. So what I'm doing is I'm dividing -1 by -4/3 to make one line the subject. Now, since I have my gradient, there's a point K. This point K is -17 and -5. So I'm going to use that. I can use the proposed formula of y is equal to mx plus c. Okay. And then I look for the values. So this is my x, that's my y. So -5 is equal to 3/4 times my x, which is -17 plus c. This is -5. When I simplify that, I'm getting -51/4 plus c. Then I'll move this -51 to that side to make c the subject. So it's -5 plus 51/4. That's going to give me positive 31/4. That's my c. So which means my y is going to be 3/4x plus 31/4. Bingo, done. Then 4.4. They're telling us that the quadrilateral PSMR, PS PMR. This is interesting. Let's see. PM. PSMR. Okay. This is the quadrilateral that they're focusing on. Then they want us to find, is it the perimeter? It's the perimeter of PSMR. So one thing we know is that perimeter is the total distance around the shape, but we know that PM, not PM, PS is going to be the same as PR, because this is a tangent and this one is also a tangent. So tangents from a common point must be the same. We also know that MR is the same as SM. That is, they have the same circle. So we already have this and that. All we need is this distance. One of them. Either we get the distance PS or we get the distance P. What are you gonna do? So since I have the equation of this line, we say 3 over 4x plus 31 over 4. Then I have this equation. I can get the coordinates of this. Okay, and then I'll know that my coordinates of R are -6 and -8. By draw straight line. It's going to be the coordinates. So if I can get the coordinates of P, then I can use my distance formula to, I wouldn't even need a distance formula since I'm going to have the same -8 somewhere here. I can get this -8, substitute it into this equation by the y, and then I equals done. I'll get my P, get the distance, and then I'm ready to go. All right, so I'm gonna say that at P, y is -8. Then I'm gonna substitute this there and say that -8 is equal to 3 over 4x plus 31 over 4. I am seeing that I have a denominator of 4. I can multiply through by 4. So times 4, times 4, times 4. This cancels that, cancels that. Then I'll have a -32 is equal to 3x plus 31. When I move this that side, we'll have a 63 negative is equal to 3x. And then I can divide both sides by 3. Okay, so which means my x is going to be -21. So the coordinates of P are -21, -8. The coordinates of R, remember we say -6 and -8. Okay. Then for us to get the distance between these two, since the y values are the same, let's just focus on this. Get the bigger value, -6 minus the smaller value. Okay. When I do that, I'm getting 15. Are you sure? Are you for real? Yeah, 15 minutes. Okay, then perimeter. So remember, if I get my perimeter, the conditions will say PS is the same as PR. PS is the same as PR. Reason, the tangents from common point. Okay, then we said MS and MR. MS is the same as MR, that is radii, okay? So which means our perimeter is going to be 5 plus 5 plus 15 plus another 15. That's 40. I'm getting 40 units. Then 4.2, we want us to get the ratio. We can get the area of NPS over the area of the entire quadrilateral. NPS. AP. this. Just change this to big things. So if we draw something for this area here. But one thing we know, this was a 90, no? The tan radius. So even this must be a 90. So that's the right angle triangle. We know this is a 4. This small distance here is a 1. So which means that total distance there is going to be 5 units. We've assumed this to be 15, since we said this is the same as that. So we can area of that. Then they want us to get the area of this entire quadrilateral. I'm gonna split this quadrilateral into 2 also. Since I don't know what type of quadrilateral it is, but I can see right angles. That's a 90. That's also 90. So it's literally going to have the same area. So 15 and 5. All right, so what I'm going to say, area of NPS. Area of NPS is going to be a half base height. And let's say over the area of the quad, which is also 2 times a half. Also going to say times half base height. Let me call this height 1. It's the same base, not a problem. So that's going to be a half times our base. We said it's 15. Okay. Our height was a combination of 4 plus 1. Then over, this is 2 times a half. Okay. Our base is also 15. This 15 under 15. Height is 5. So why am I saying 2? Because we have 2 of them. This is number 1. This is number 2. When I combine them, I have the entire area of the whole shape. Okay, so this 15 is going to cancel that 15. This half is going to cancel that half. 4 plus 1 is 5. And then this 5 will cancel. So which means I'm getting a half as my ratio. Okay. That was pretty good. All right. Let's move on. Question number 5, which is Trig. Trig, here we come. All right, so with question number 5, they are telling us without using a calculator. Now we don't need to use a calculator in this. We just need to follow our identities. Okay, remember they want you to express this into a single trig ratio. So follow the identities of the reduction and all of that. Okay. So I have 1 minus sine negative theta cos 90 plus and cos theta minus 360. What do I see? Okay, so I can see some element of complementary angles. I can see a reduction part and even this. So if I can play around with that, then I'm good to go. Okay, step number 1. What I'm going to do, remember it is 1 minus sine of negative theta cos of 90 plus theta. I'm dividing it by the cos of theta minus 360. Okay, so that's 1 minus the sine of a negative angle is the same as you put in the negative outside, so that's what means the positive angle. I'm multiplying by the cos of 90 plus must give us a negative sine of the angle. You can open this using compound angles, but we know from our reduction of complementary angles that cos must give you sine and sine must give you cos. Then down here, the cos of theta minus 360, this does not matter for as long as it is cos. It only matters when it's a sine or a tan. Okay. Because someone will say, let's first factorize out the negative. Okay, we can do that. It's a negative so that we have a normal representation of the reduction. But we know that the cos of the negative angle is the same as the cos of the positive angle. That's why we said this doesn't really matter, but it's okay. Simplify that, we're going to have 1 plus the sine of theta multiplying by negative sine theta over 360 minus is in quadrant from your cast down. Okay, this is 180 minus theta, 180 plus theta. This is 360 minus theta, and then this is 360 plus. Okay, so we're gonna find it in the fourth quadrant. In the fourth quadrant, cos is positive, so that's gonna be the same as cos of theta. Okay, this negative is gonna affect that, so this is gonna become, let me just write it here. It's gonna be 1 minus sine squared theta over cos theta. Then from our formula sheet, you know that 1 minus sine squared gives us cos squared theta over cos theta. Then we can just reduce that to just a cos. There we go. All right. So that is done, that is done, that is done. 5.2.1 for 2 marks. Telling us if you've been given cos 20 to be a p, calculate without, you don't need a calculator for each of the following in terms of p. So in terms of p simply means our answer must have a p attached, okay? And then with these angles, we always need to find a way of expressing them with either 20 or a multiple of 20 at most. Okay, so the first kind of scenario we need to do, come up with a sketch. Okay, whether you're gonna need it or not, just come up with a sketch. In most cases, we need it. Okay, so that is a 20. And then they told us the cos of 20 is p. So this is the same as p over 1. Okay, there's nothing at the bottom. So cos is adjacent over the hypotenuse. So this is a p, this is a 1. And then from our theorem of Pythagoras, we need to find the missing side here. This is going to be 1 minus p squared. Okay, if you get x squared plus y squared must be equal to r squared. So our r is a 1. Our x is a p. And then our y is what we're looking for. Move this that side, you get 1 minus p squared, and then you find the square root on either side. There we go. So this is done. Okay, but they want us to get a cos of 200. Then cos 200, how or which numbers do we play with so that there's a 20 involved? We can either reduce, because we can't get 100 from a triangle, remember, just introduce it to an acute angle. So looking at this, I can say cos of 180 plus 20. That gives me 200. So I must get the same result, but represented in a format that I can reduce. So 180 plus, that is quadrant number 3. And in quadrant number 3, cos is negative. Okay. So this is going to reduce to a negative cos of 20. Question told me cos of 20 is p. What about the negative cos of 20? So that's going to be a negative p. And then we're done. Then 5.2.2, the sine of negative 70. Okay, so remember, if you have a negative angle, first move the negative outside. So negative sine of 70. Then the question is, which number do I play with to give me 70? But that number must have a 20 attached. So I can use 90 minus 20. Okay. If I use 90 minus 20, this is still complementary. So it's going to be negative, but with a cos of 20. Okay. Then still, which is the same as the previous question, which means our answer is a negative p. Then 5.2.3, they want the sine of 10. Sine of 10. So now, what is happening? We have a 20 and then we have a 10. So we can see that 10 is just a half of 20. Okay. So what I'm going to do I can try to use the, I don't know, what can I use? The double angles. Is that going to make sense? Yes, it can make sense. Let's say I have cos of 20. And then I have to reduce this. Know that cos of 20, but let me just say that 20 is the same as 2 times 10. Okay, I just want to look at cos 2 times 10 of the cos, okay, the double angle of cos. So this can be given as 2. Should I use cos? Should I use sin? It's fine. I'll say 2 cos squared 10 minus 1. I can just use the because I know it is going to be cos squared of minus sin, which is 1 minus 2 sin squared of 10. Just take this out, this goes. I'm going to say 1 minus 2 sin squared of 10. Okay, so I have my sin 10 represented. I'm still having my cos 20 beside. If I try to make sin 10 the subject, let me just switch this so that I have 2 sin squared 10 is equal to 1 minus cos, say 20, because 2 times 10 is 20. Okay? Then I'll divide both sides by 2, so sin squared 10 is equal to 1 minus cos of 20 divided by 2. Then I can take square roots on either side to eliminate that. So that my sin 10 is going to be the square root of 1 minus cos of 20 over 2. Okay. But whenever I find the square root, I can have a plus or minus, but that's not a big deal. Okay. Then I can now do the substitution. What was the question saying? The question was talking about the cos of what? The cos. Was it sine or cos? Question, what did you give us? Give us cos of 20. Is the same as the p. Okay, so when I do my substitution, I'm having plus minus the square root of 1 minus p over 2. That's my answer. That is the sine of 10. All right, then 5.3. Determine without using a calculator the value of this. So this is a cos a plus 55, a plus 10. So it's a cos, and then plus a sine. So if I hold the whole of this to be my A and the whole of this to be my B, this is a compound angle kind of question. Okay. So we have a cos. Okay, so we have the cos of A plus 55, and then the cos of A plus 10. Okay. Then we're saying plus the sine of A plus 55 times the sine of A plus 10. So from the the compound formula, I can see that we are combining just cos. So if that is my A and that is my B, so if I have the cos of A minus B, that's when I can expand this whole kind of thing. I have cos plus when there's minus in between. So I'm gonna have cos, this is A plus 55 minus the A plus 10. Okay, so that's a cos of A plus 55 minus A minus 10. So that reduces to a cos of 45. And then from our special triangles, that is a 45, that's a 45. So 1 and the 1 and the root 2. So cos of 45 is just the same as 1 over root 2. Okay. And then 5.4.2. No, 5.4. 5.4.1. Okay. They want us to prove the identity. Prove the identity. So with proving, we have the question and we also have the answer same time. So that's a cos 2x. Are you sure, Maluma? Yes. Plus sine 2x. Okay. We are subtracting cos squared x. And then we are dividing this whole thing by sine x minus 2 cos x. They're telling us this must reduce negative sine x. Okay, so one thing you need to know is that when you're proving, you need to start from one side so that you get to the other side. And if that is being done, do not involve both parts into your proof. Just work with one and then end with the other. So I'll say that I'm starting from the left-hand side. Okay, I'm seeing the double angle cos, the double angle sine. And then on my right-hand side, I'm only having sine x. All right, what am I gonna do? Let me change this. I'm gonna change everything to sine, if possible. Okay, so I'll break down the cos 2x into something like 1 minus 2 sine squared x. Okay. 1 minus 2 sine squared x plus the sine 2x is going to be 2 sine x cos x minus this is cos squared x. This is over the sine x minus 2 cos x. Okay, when I change that, okay, what next? What next? What do I see? Is there anything that I can combine? Yes, I can combine this. If not, I can change this to 1 minus sine. 1 minus 2 sine squared x plus 2 sine x cos x. Then I'm going to have 1 minus, so negative 1 minus sine squared x, which is going to give me negative 1, then plus sine squared x. And this by the sine x minus 2 cos x. So is there anything that is common for me? So this is going to cancel that. This is going to reduce that. So I'm going to have negative sine squared x plus 2 sine x cos x over the sine of x minus 2 cos x. That is common there. You can see there's a sine x and there's a sine x. Check out the negative part of it. Okay. I'm going to take negative sine x outside. I'll be left with just a positive sine x minus this and that, 2 cos x. I'm dividing it by sine x minus 2 cos x. Okay, so this and that will cancel. Then I'm left with just negative sine x. Negative sine x. Okay, so which means my left-hand side is equal to my right-hand side. Okay, so that is that. Should I 5.4.2. They want us to determine the value of this working. Okay. So when I look at this, Does it look like the top part? This, and that, okay. And then I'm seeing the bottom part, there's a sine squared. And then there's a cos, which means there's an introduction of something extra here. Okay, let me see if I can break this down into my original equation. Okay, so I have the same top things, which is cos 2x plus sine 2x minus cos squared x. And then we're dividing it by, remember it was -3 sine squared x plus a 6 sine x is that true? Plus x. Okay, so let me try to create the original. So I'm going to have cos 2x plus the sine 2x. I'm not going to expand anything. I'm just going to reduce it. So we are saying something extra was added here. So I'm going to take that extra. Since there was a 2 here, and there was nothing here, I'm going to take whatever is in front of it, which is a 3. So -3 must come out, but it must be a -3 sine. So since I'm seeing an extra sign, okay, so I'll be left with just one single sign. This is going to reduce to a negative. The raise out, so it's a 2 plus x. Okay, so this whole thing just looks like my original expression. Remember, this whole thing was the same as negative sine x. Okay, so I can replace this whole thing by sine x and then I multiply by that. So that's going to be negative sine x times 1 over -3 sine x. So this sine x is going to cancel that sine x, negative and negative, and I'm going to have just 1 over 3 as my answer. Okay, and then 5.5.1. If you're given 3 tan 4x is equal to -2 cos 4x, without using calculator, can you show that this is the only solution? It's a sign. You don't have anything like tan. Okay. So 3 tan x, no, 3 tan 4x is equal to -2 cos 4x. Okay, I'm gonna change this from that identity. Okay, I'll say 3 sine 4x over cos 4x is equal to -2 cos 4x. I can solve for 1. And then I'll do my cross multiplication. I have 3 sine 4x is equal to -2 cos squared 4x. 2. And then I can change this to a sine. I have 3 sine 4x is equal to -2 into 1 minus sine squared 4x. And then I'll open that up. Okay, I have a -2, negative and negative. I have a +2 sine squared 4x. I'll move this that side so that I have 2 sine squared 4x minus 3 sine 4x minus 2 is equal to 0. Okay, I'll try to factorize this by opening my 2 brackets. Let me just change the color. Okay, there's a 2 there, so which means I'm gonna have a 2 sine x and maybe a sine x there. Which numbers do I multiply to give me -2? It has to be a 2 and a 1. Okay, the signs, one must be positive, one must be negative. We make this a negative and a positive. That is 2 sine squared. This is -4 plus 1. Okay, That's fine. So from my dot product, this sine x is going to give me negative a half. Or sine x must give me a 2. But when you're finding solutions, remember the angle or the result of sine must always be between 1 and negative 1. It cannot exceed that. So since this is exceeding 2, we don't have anything like sine x is equal to 2. So this is not applicable, but this will give us the solution. When you draw your conclusion that therefore the sine x is equal to negative 5 is the only solution. Remember, negative a half is the same as negative 0.5. Then 5.5.2. Hence, determine the general solution. So general solution, since I've told us this is the only solution, we only need to get what we call the reference angle. Okay, if we get the reference angle, then we're good to go. So our sign is negative, né? So we're gonna look at quadrant number 3 and then quadrant number 4, because those are the only quadrants where sign is negative. Then for me to get my reference angle, I need to say x is the shift of, which is gonna get it. Just ignore the negative. That negative is used to identify quadrants. And then in quadrant number 3, okay, my x is gonna be equal to, remember in quadrant 3, that's where we have 180 plus. I'll just write everything there. So it's 180 plus 30 plus sine, which is 360 times k. Remember, sine and cos is a period of 360. It's only tan that uses 180. Yeah? All right. So, sorry, something is amiss. Something's amiss. This is meant to be 4x. Even here. So 4x. That 4x. Okay, so which means that is still our 4x. Please do not divide the 4 and the that as yet. So which means our 4x is going to be a 210 plus 360 times k. We divide through by 4, we get x alone. What is 210 divided by 4? That's 52.5. Plus 360 times, oh, even 360 must be divided by 4. What's wrong with me? So that's going to be a 90 times k. K is an element of integers. So if it's a division or a multiplication, it affects everything. But if it's just addition or subtraction, it affects just the angle and everything of the left-hand side. That is quadrant number 3. Then in quadrant number 4, I'll still have my 4x is equal to 360 minus 30 plus 360 times k. Remember, the quadrant 4 is represented with an angle. Then 360 minus 30 is 330. I'll divide by 4. Okay. 330 divided by 4 plus a 90 times k. 330 divided by 4, getting 82.5 plus a 90 times k. K is an element of integers. Okay, so an element of integers simply means you can just replace k with the normal integers of negatives, positives, as well as the zero to get our solutions. Okay, so guys, that is that. Question 5. Question number 6. Okay. Question 6, they are telling us that in the diagram we have these graphs, but we only focusing on negative what? Negative 90 and positive 180. And that's our domain. K, we have f of x is tan of x minus 45. So this negative simply means the graph is shifted, because this is a phase shift. Shifted 45 units to the right, so which means it was meant to be somewhere here, that has been shifted to somewhere there, 45 minutes. Same applies with all these arms. Nevertheless, they want the period of f. So when you talk of period, it's like after how many intervals do we see the full graph? Okay, so this and that becomes the full graph from here up here. Since we have that and then this bottom part, then we have that and this bottom part. So these are two graphs of time. So our period, since there is nothing in front of x, the period is just going to be 180 degrees. Okay, so that is 180 degrees. Then they want us to draw negative cos 2x between the same interval. So all the intercepts with the axis and the minimum, maximum turning points. So from your calculators, no? Remember, we got mod, and then the table, get f of x, then we're gonna put negative cos 2 alpha and x, close the brackets. We don't have a g, so we can ignore that and just press equals. We're starting from negative 90. We are ending at positive 180. Our steps, are using the steps of 45. Then we have our table. Okay, so remember we said mod, go for the table, and then from the table you enter the function f of x, which is negative cos 2x. No, it's negative cos, not negative. Okay, then I'm gonna give you the starting point. Start is where the domain starts, which is negative 90. And then the end, we're gonna use 180. And then for the steps, these are the intervals from 0 to 45, according to the grid that we've been given. Okay, that's a 45, and then we sketch. So from what I have, I'm having negative 90 with a 1. Okay, just remove this. And then negative 45 is a 0. 0 is a negative 1. 45 is a 0. Then I'm having 90 to be 1. And then 135 to be 0. And then 180 to be negative 1. Guys, remember, this is a graph, not a line. So in as much as the points may not really be sufficient, just try to make sure that this looks like a curve. Okay, some people will force a line out of this. Use that. It's a graph that you join using free hands. I may not be that accurate, but I'll try. Okay. So have something like that. It's gonna turn something like that. Okay, so that is my graph of, we call it G. Okay, done. Then they want us to write the range. Remember, range represents the y values. So according to the graph, I can see that the minimum point it can go to is negative 1. And the maximum that it can reach is a positive 1. So I'm going to say negative 1 is less or equal to positive 1, because it is passing through negative 1 and positive 1. So I must use the equal sign as well. Then 6.4, the graph is shifted 45 units, the graph of G, to the left. From the graph of what? H. can we determine the equation of H in the simplest form? So when you shift something 45 to the left, it must be represented with a plus sign in that front. So where there is x, remember it was negative cos 2x. No? So where there is x, I'm going to represent with that shift. So x plus 45. I'll open that up. I'll have 2x plus a 19. Okay, when I simplify this, remember it's a complementary angle. I have a cos of 90 plus. That's going to give me a negative sign. So negative and negative sine 2x is going to give me a positive sign of x. So which means my h of x will be given as that. Okay, then 6.5, use the graph to determine the values of x for which. So using the intervals of negative 90 and positive 90 only. Negative 90 and positive 90. Not 180. Okay, so for which we want f of x to be greater than 1. So where do we find the graph of f to be above 1? Okay, so we can see that this area, the graph is above 1. What are the values of x between this and that? And then above 1, at this point it's at 1, but we said our end point is 90. We can't go beyond that. So for f of x to be above 1, I'm just going to say negative 90 and then. So my answer is going to be negative 90 is less equal to x and less than 45. Since the graph is not touching the line of 45, so I'm not with the equal sign, but it's passing through the 90. Then the next point, next question, 6.5.2. They're telling us that if we have 2 cos 2x minus 1 is greater than 1, for which values of x is that? So what I'm going to do, I'm going to try to work around this and create this original. This is a 0. So I'll start by moving the one to that side. So say 2 cos 2x minus 1. Yes, it's greater than 0. Move the one that side so that you have 2 cos 2x is greater than positive 1. Then I'll divide both sides by 2 so that cos 2x is greater than a half. Then when I multiply through by a negative or divide through by a negative, this inequality symbol changes. So that's negative cos 2x will be less than a half. So which means the question is asking me for the values of x for which g of x, okay, is less than negative a half. Okay, so from the graph of g, just go back. If I have this as my half, the negative, I want this value here. Okay, this value here. Only those ones, because those are the only values where this graph is going to be below negative a half. And remember, he told us between negative 9 and positive 9. So we cannot include the issues of this part. So our focus is just that area. So from our trig, we know. Okay, but if we were to look at the arc side of a half, remember we're not meant to use calculators. That's going to give us a 60. Positive or negative doesn't matter. Then when you divide by 2, that's when you get a 30. So I'm going to say negative 30 is less x. That's equal to positive 30. For which values? They say greater. Okay, if it's greater, and now we found less, I don't need to put the equal signs, you know. That's wrong with me. Yeah, negative 30 less or equal to 30. The previous question, they said greater than 1. So it means there's no need for the equal sign. All right. That is question number 6, guys. Let's go to question number 7, which is the application of trig. Question number 7. So in this question, at least we need to know about the area rule. Okay. We must know about the sine rule and then the cosine rule. Those are the 3 that govern this question. If we know that and not play around with it, then we good to go. Then question 7, they are telling us the diagram A, B, C are points in the same horizontal plane. So horizontal is like just the same flat surface. That's a plane on its own. D is a point such that it's above C, in that DC makes a 90-degree with AC, and the same with BC. It's given that our ACB is 100, CAD is 30, AD is 20, and then BC is 18. So everything is indicated for us. Okay. Then they want us to get the length of AC. So is AC, this is AC. Now this AC is surrounded by 2 triangles. We have this bottom triangle, this angle. Now I see that the triangle with more information is the ACD. It's a line close, so I can use that. So I'm going to say from ACD, okay, from triangle ACD, I can use the Trig ratios now. Because I need this, I have that. So this is our hypotenuse. This is our adjacent. I can use the cos. So we're saying the cos of 30 must be equal to the adjacent, which is AC over 20. When you cross multiply, that's going to be 20, the cos of 30. And that's going to give me 10 root 3. I can write it as 17.1. They tell us about newtons. Just call it units. So I'm gonna just stick with the 17.32. When 7.1.2, they want the distance AB. This is AB. Okay, so with AB, this is 17.32. For me to get my AB, then I need to use the bottom triangle. And which rule am I going to use? Let me use the cosine rule since I have 2 sides. Okay. So I'm going to say that AB squared is going to be the same as AC squared plus BC squared minus twice AC times BC, the cos of BCA or ACB. Then my AB is going to be the square root when substitute. AC will get 17 squared. This is 8 minus 2 times 17.32 times 8. And it's over 100. I'll put this into the calculator straight out. 20.30. 20.30. Then now 7.2 if it's further given that ABD, so all of this angle is 73.4. And we find the angle AD. Wait, that's not. That is what we want. Okay, we've been given ABD, all of this to be 73.4. So this angle goes with that. This angle can go with that. Remember this second one. So which means we can use the sine rule. Okay. So from our sine rule, which triangle are we using? The triangle ABD. I'm gonna say, since we're looking for an angle, I'll start with the angles. Sine of D over AB. Sine of D over AB must be equal to the sine of D over sine of D over the distance, which is AD. Then I'll do my substitution. Okay, so that is the sine of D, which is like ADB over our AB that we got as 20.30. It must be equal to the sine of the angle that we're given, which is 73.4 over the distance, which is a 20. I'll cross multiply. So it means the sine of ADB. So 20.4. The sine of 73.4 over 20. Let's simplify that. Sine of ADB is giving me 0.9727, and I must find the shift sine of that. I'm having 76.58 degrees. All right, question number 8. Euclidean geometry. Okay. With question number 8, they're telling us that in the diagram, O is the center. KTL points, these ones are drawn, OT intersects that at M, and then you have a tangent. So this word here, okay, big O. And then they're telling us that STK, that's a 36, okay. This is 18. Okay, first question, they want us to get T2. Now, one thing we know, before we get T2, if this is a radius, and then this is a tangent, we know that the tan and radius must be perpendicular. The tangent and the radius must be perpendicular. So which means T1 plus T2 must give us 90 degrees. That's what we got to start with. So I'm going to say T1 plus T2 is 90 degrees reason, the tan perpendicular to the radius. Okay. Then if I have T1 as a 36, I can find 92. So 36 plus T2 is a 90, and then I'll transpose that. So which means 92 becomes 54 degrees. Okay. Then they want us to get L. So if this is a 54, this is L here. Now, one thing we can also see is that since this triangle KLT is touching the ends of the circle, and this angle is between the tangent and the chord, it must be equal to that. So I'm just going to say that L is a 36, The reason is because of the time code here. Okay. That's gonna be the time code here. And then with C, they want me to get the angle K O T. K O T. So this angle here. Okay. All right. So one thing I'm seeing, I don't want to overthink things. What I'm seeing is that since this 36 is at the same as at the circumference, and this KOT is at the center, it's forming that angle at the center is twice angle of the circumference, but in a flipped way. So this must be twice of this, since these are the angle, because the two angles are being created by the same coordinate. So which means KOT is 72 degrees. Let's say angle at the center is twice angle at the circumference. Okay. So that is 8.1.2. We move 8.1.2. Can we prove that Km is the same as Ml? Km is from here up here is the same as Ml. Okay, so if this is a 36, this is a 54. One thing I'm saying that this line is common. Okay, I don't know, I would look at maybe trying to prove what we call this thing, congruence in this case. Because I can find what K1 is so that I focus on two triangles. Same focusing on this triangle. And then we're gonna also focus on this one, look for what is common. And get the reflex to relate the two, then automatically that will be also the same. So what I'm gonna get, let me try to find the whole of K. So K is gonna be 54. The reason is gonna be angles opposite equal sides. Because we know that this is a radius, this is also a radius. So this is an isosceles triangle. So this 54 must be the same as that was 54. Then if the whole of it is 54, then what is K1? That is 54 minus 18. Okay. So 54, come on. 54 minus 18, that's gonna give me 36. So K1 is a 36. Just K1. If there's a 36 here, then there's a 36 here. Then I can see that this is common. Then my question is, what is this angle here? Okay. What is that angle? Okay. So if I try to find this missing angle T2 and T3, I'm gonna look at the triangle KTF. So the 36 and a 36, which is a 72, which means that's gonna be 108. So angles in triangle P2. If that is 108, but this is a 54, which means T3 is going to be 54. So what I'm going to do, I'm going to say that T3 is the same as T2. Prove that. And then we see that L is the same as T1. We've also proved that. And then we see that Tm is common. Okay. Therefore, KTM is congruent TML because of the two angles on one side. Say angle, angle, and side. Then if the two are congruent, then we can see that the side that is opposite the 54 is ML and that, which implies that KM is the same as ML. So that's how I would have gone about with that question 8.1.2. Start by getting these missing angles, prove the congruency, and then I'll draw the conclusion. So that is 8.1.2. All right, then 8.2, they're telling us that the diagram RDS is drawn. A, B, and C are points on RD. Okay. Such that that and that and that. AB is parallel to that. RB, the ratio of RB to BS is 5:3. And then BC, that's a 20. And then can we prove that BC is parallel to 80? Can we prove that BC is parallel to 80? So what I can do, for me to prove that BC is parallel to 80, I need to look at this triangle in this format. If the proportion, if my CS, let's say over CD, is the same as BS over RB, as long as these ratios are satisfied, then automatically they'll be parallel. Okay, so step number one, state number one, I'm gonna get CS. What is my CS over CD? That's gonna be 12 over 20. When I simplify that, I'm getting the 3/5. And then we know that BS over BR is also going to be the same as 3/5. Okay, so then I'll say, just write CS over CD is equal to 12 over 20, we get 3/5. Okay. And then I'm saying that BS over BR is also 3/5. And then since CS over CD is the same as BS over BR, okay, therefore BC is going to be parallel AD. It's AD, but we also take it as DR. Okay, so okay, so these two lines are parallel. The reason is going to be the converse of the proportionality theorem. Okay, so that is our first question. 8.2.1. Then 8.2.2, if it's further given that RD, okay, what's happening here. Now they're telling us that RD, the distance from here up to there, is 48 units. Is that true? Yes. Calculate the ratio of AD to AB. So the ratio of that to that. Okay, so what we're going to do, we know that AB is going to be the same as DC, because if that is, remember we've proved that these lines are parallel. And then initially they told us that these lines are also parallel. What does that make this whole ABCD thing? So ABCD is a term. It's a parallelogram, okay? So if AB is the opposite side of DC, so I'm saying AB is also going to be 20 units. These on opposite sides of a term or parallelogram. So if that is a 20, all I need to find is the size, okay? The size of AD. Then I can go back to my triangle RDS, okay? RDS, and say that from RDS, if I use my proportionality theorem, if I get my AD over the total distance RD, okay, AD over RD must give me the same thing as BS. Okay, just this, I'm comparing it. Okay, so I'm having BS over the total length, which is RS. Okay. The reason is going to be proportionality theorem, because AB is prior to, so AB is prior to BS. Okay, then I'll substitute. What's my AD? That's what I want. So AD is going to be the same as BS times RD over RS. So our BS, we said, was 3. And then I'm multiplying the 3 by the RD, which is a 48. And then I'm dividing it by 5 times 48. No, not a 5, guys. It's not a 5, it's not a 5. RS is 8. So that is the total length. It was 500. Okay, so it means I'm having 18 units. Okay. If it's 18, which means the ratio of AD to AB, I'm gonna have 80 is to 20. Because our AB was a 20. Remember, initially we said this. So when I simplify this, I'm gonna have 9 is to 10. So AB is AB. That's gonna be 9 is to 10. All right, guys, that is question number 8. Then question number 9. In the diagram, if O is the center of the circle, ABCD is a cyclic quadrilateral. Let's remember the properties of a cyclic quadrilateral. This is our center. Can we use answer book to prove this theorem that the opposite angles B and D are supplementary? It's okay. I can use this. So in most cases, there's construction that is needed. Okay. So if I'm proving B and D, which means my construction, I can extend a line to O, then I can extend that. Okay. I can call this top part 1. I can call the bottom part 2. Then I'm gonna say that my O2. Okay, because O2 is the angle at the center, which must be the same as 2 times B. So O2 is twice B. Reason is angle at the center, angle at the center, center. So the twice angle at the circumference, so we can write the full word. Then consequently, we can say that O1, this angle here, is also at the center. It must be twice the angle at the circumference. It's the same as twice D. So angle at the center is twice angle at the circumference. Okay. But we know that our O1 plus O2 must give us 360 degrees. Reason, those are angles at a point. So sometimes we just call it a revolution. Then when I substitute my O1 and O2, that's going to be my 2D plus my 2B being equal to 360 degrees. Vector out the 2, I'll have D plus B being equal to 360, and then I'll divide both sides by 2. So that I have my B plus D being equal to 180 degrees. So I think the proof is done. So angle B plus angle B must be equal to 180 degrees. So that is how you go about that. Okay. There are other ways, but I find that the easiest approach. The 9.2, since we proved about the cyclic chord, which means the second question, now you should be related to that. So in the diagram, DEFG is a cyclic chord. Okay, such that this EF is parallel to DG. And they're telling us H is another point in the circle such that this is parallel to that. Okay. Can we prove, given reasons, that D1 is the same as D2? Okay, so we know that opposite angles of the cyclic chord are supplementary. That is number one, since we don't have anything like exterior angle here. Then we're going to play around with parallel lines. So if I can find this angle, then I'm going to need to get this G. And it is this G that will be the same as that to the ultimate angles. If that is possible, then I've proved my question. Okay, so step number one, I'm going to say that F is 180 minus X. The reason, opposite angles of the cyclic chord. Okay. Then if F1 is 180 minus, then I need to find G. I'm saying G is going to be X. Reason, these are co-interior angles. They are co-interior because EF is parallel to DG. Remember when you said if you have two parallel lines, this angle and this angle must add up to 180. Okay, so if this is 180 minus X, this is too small. Explanation. Okay, that is 180 minus X. This is a second angle that we don't know. Maybe P plus 180 minus X must give us 180. That is the rule about co-interior. Then when you move the 180 that side, it's going to die out. You move the X that side, which means it's the same as X. That is the principle that we're using. So if G is X, then D2 is also going to be X. Why? Because these are alternate angles. This angle. So we're going to say alternate angles because DH is parallel to FG. Then if that is true, since D2 is X, and to a conclusion. Therefore, D1 is the same as D2. Yeah. Comments. Then question number 10. Question number 10. They're telling us that in the diagram, TR is a diameter. It's here. This is a diameter, that is the center of plane. And then PRKT is a cyclic chord. Let me just highlight that. It's the cyclic for us. Okay. And then the chords TP and K are produced to intersect at the point base. It's fine. Chord PK is drawn such that PK, this one, is the same as this one. PK. All right, okay. Then prove with reasons that SR is a diameter. The circle that is passing through SP. So if we have a circle that is passing through SP, what do we know about diameters? So for as long as we have a diameter, it simply means that the angle that is opposite to the diameter must be negative. So this question is literally asking us to show that if there is a 90. If you can prove that, answer the question. Okay, so what I'm going to do, how do we prove that P3 is 90? Okay, so I'll start by finding K. Remember, they told us that this is a diameter. Let me start from here. Okay. That is a diameter, and there is a proper circle that is within, sorry, a proper triangle that is within that kind of format, which means P1 and 2 is going to be 90. I can look at that, or I can say K1 and K2 is a 90. So I'll use the P1. So I'm saying P1 plus P2 is going to be 90 angle in a semicircle. Okay. So if that is a 90, which means that P3 is also going to be 90. This one is going to be angles on a straight line. And angles on a straight line must be supplemented. So that we have this 90 of P1 and P2 and this 90 of P2. So if that is a 90, then that is enough to prove that if we add a circle here, okay, then this will be the diameter, since this diameter is opposite to the 90. So having said that, I can just draw that conclusion. Therefore, our SR, SR is a diameter. SR is a diameter. What was the question asking for? Can we prove that SR is a diameter? That. Okay, so we proved that that angle is a 90. Okay, we proved that that angle is a 90, which means SR is a diameter, and we're gonna use the converse of it. The reason is converse of angle in a semicircle. That is one approach. The other approach was for someone to look at this K1 and K2 and then that 90. And if that's a 90, which means P3 is also a 90 because of the exterior angle of the cyclic quad. And then you draw the same conclusion. Then 10.1.2, they want us to prove. Can we prove that S is the same as P2? S is the same as P2. What do we do? What do we do? S is the same as P2. Okay. So from this drawing line, I can see that R1, this angle, is going to be the same as T1 and T2. Because that is exterior angle of the cyclic quad. Okay. And then okay. Since they told us that TK is the same as P2, I'll start by saying that T1 plus T2 is the same as P1. Okay, this one is going to be angles opposite equal sides. That's when I look at this triangle, that is in triangle TPK. Okay, if that is true, then I'm seeing that R1 is going to be the same as T1 plus T2. The reason is going to be exterior angle of the cyclic quad. Let me write it this side. Same T2 plus T1 is the same as P1. Reason angles opposite equal sides. And then the same R1 is the same as T1 plus T2 because of exterior angle of the cyclic quad. Okay. Then if that is true, that this and this are the same, and then that is also the same. What does this mean? This simply means that R1 is the same as P1. Does it make sense? Yes. Say P1 and R1, they are equal to the same thing. Therefore, P1 is the same as R1. Okay. Go further and see that in triangle, this P. Remember, this was meant in triangle. This RP. We know that P1 and P2 are going to be 90, same as S and R1. Okay, let me start by saying P1 and P2. P1 plus P2 is equal to 90. Those are the opposite angles of the cyclic quad. If not, we will prove that the angles in the same side. Let's just stick to that. Okay. Angle in the same side Okay, so if that is true, which means even S and R1, if this is a 90, it means S and R1. S plus R1 must also be 90, and this in triangle SRP. Then I can equate this two. I'll say, I hope it makes sense, guys, not one crucify. P1 plus P2 is the same as S plus R1. But we say that P1 and R1 are the same. So this and this are the same, which means that P2 is the same as S. Ten 10.1.3. Question is asking us to prove that SPK is similar to PRK. SPK, just highlight it. That SPK, this big triangle, is the same as, which one is the black one? PRK. This one. Let me put that as okay. So from the drawing, I'm gonna say that K2 is common. Okay, for both triangles, since both of them are sharing this K2. Then what we just proved was S and P2. The same S is the same as P2. S is equal to P2. We just proved that. Which means this is gone. So it means R2 plus R3 must be the same as P2 plus P3. The reason is going to be the remaining angle. All right, so same K2 is common. Okay, previous question, S is the same as P2. Same, we proved that up. And the R2 and R3 must be the same as P2 plus P3. Reason, that is the remaining triangle. Just remaining, and it's fine. Therefore, having obtained that, yes, we have prefix, then we can say that SPK is similar to PRK. The reason is going to be angle, 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 or you can just use triple A, no problem. 10.2. 10.2. It's further given that SR is the same as RK. But this angle, so that side is the same as this side. It's disorganized, but it's given use a clean one. Okay, so this is the same as that. Okay. Now they want us to prove that ST, can we prove that ST is 6, no, root 6? What? Okay. Okay, so what I'm gonna first of all do is, since we're looking at ST, which is, and we know that K1 plus K2 is 90 because of angle in the same circle. Okay. That's 90, then this is a right-angled triangle, and you can apply the Pythagoras theorem. We'll have S squared is equal to TK squared plus SK squared. Okay. But before I go there, let me first of all look at this triangle. The PSR and the friend. This is PSR, that is SPK. So if I have this kind of format, just gonna read through it. This is SPK. I know this is my P.2. Okay. And I draw the small one. It's gonna be okay. Say K is common. Say P2 is the same as, so there's a P there. Say this is gonna be R. Okay, my question just has R. Okay. So I'm gonna try to eliminate R. Is that even possible? It's possible. Very possible. So I'll ignore this side and that side. Let me try to look at this. So I'm gonna say SK over PK. It's gonna be the same as PK over KR. Okay, what's the reason? That's going to be the proportionality sides of sides and proportion. Proportion sides because of similar triangles. If I make PK the subject, which means PK squared is the same as SK times KR. And this, I need it. All right, then I can just go back and know that our PK is the same as the TK from the question. We told that PK is the same as TK. So where I see a PK, I can replace it with a TK. So that I have my TK squared is equal to SK times KR. Let's get here. So this is going to be ST squared is equal to where there is TK, I'm going to replace all of this. So that is SK times KR plus, what is our SK? They told us is the same as this. So if this is RK, this is also RK. So I'm going to say 2RK squared. But I know that the whole of SK is the same as 2RK, since this and that are the same. Okay. So which means ST squared is gonna replace this to 2. I don't know, RK is the same as KR. It's the same thing. Plus that is gonna be 4 RK squared. So ST squared is gonna be 2 RK squared plus 4 RK squared. And this is gonna be ST squared being the same as 6 RK squared. Then I take square roots on either side. Then that's gonna be root 6. Square root of anything squared is just gonna be RK. So that is what we have to do. So start with the triangles and compare the proportions. Someone could have said SK over PK is equal to PK over that. That are the sides that are in proportion. So guys, that's that. No? With that question 10.2. Oops, that's the last question. All right. So guys, I We're done. That was the last question, and then I'll stop. All right, thank you very much, guys. So if there are any corrections to be made, please, you can leave them in the comments. We appreciate your feedback that you give us. That will make us better people in the future. All right, thank you very much. Let's meet in the next episode. Yes, hello, and welcome to this episode where we're going to be looking at the May, June 2023 mathematics paper 2. We call the supplementary examination. So this paper 2, it's 150 marks. It was meant to be done in 3 hours. Okay. So the instructions are, we have 10 questions that we need to look at. There's a special answer book that we shall be using. We must show calculations, and we must use some diagrams in some cases. Answers only will not guarantee full marks. There is a need for scientific calculator unless the question tells us not to use one, okay? So we need to round our answers to 2 decimals, and unless the question tells us otherwise. Diagrams are not drawn to scale, and there is a formula sheet at the end. Then we need to write neatly and legibly. Okay, so when you look at question number 1, it's usually statistics, okay? So in this case, they're telling us that the owner of a small company wishes to establish whether advertising in a regional newspaper is effective. Does it bear results? Okay. The table below shows the amount that was spent on advertising and the sales for the last 9 years. So the first year, the second, the third, and so on and so forth. So this is how much was spent on advertising. And then these are the sales, like the outcomes of the advertising after the advertising was done. Okay. So usually the amounts or the values in the top row will always represent the X. In this case, that told us those are the X values, and then these are the Y values as well. Then 1.1.1, they're telling us to determine the equation of the least square regression line. Okay, so one thing we need to know that for the regression line, it's usually in the form of Y is equal to A plus BX. Some calculators will show you these capital A's and the capital B's. And so what we need to do, we need to set our calculators into the mod function. From mod, we need to look at start. And then from start, we need to choose the regression line, which is the A plus BX. If it's not there, then you have to choose the regression equation. Then you're gonna get 2 columns that are having X and Y, and sometimes even the frequency can be indicated. Don't worry about the frequency. So for the case of the X, we're gonna enter all the top numbers for the top row. All the numbers must be entered, and then the corresponding Y values should also be entered. Once that is done, we must press the AC button, or sometimes call it clear all. If not, we must use the on button, and just to clear whatever is on the calculator. Then from that, we're gonna press Shift and 1, and then we choose the relevant item we're looking for. So in that case, we're gonna start by looking for the value of A, and then the value of B, and rewrite our equation. Okay, so when I do that, enter my values, X and Y, okay, I press the clear all button, and then once that is done, you can press the Shift and 1, and then I'm seeing my A as 1730.22. I'm getting a B of 13.96. Okay, so I want to use the answer book. Let's see if I can access it. So with this answer book, it's more or less the same information for the same table and everything. So we said y must be the same as a plus bx. And we got our a as 1730,22. We said b was 13,96. So my equation is going to be 1730,22 plus 13,96 with x. Okay, so that is the regression equation. Then question number 2, they want us to predict the cells. When they talk of predicting cells, it's like we use the regression line because that line is used to predict what might happen in the future through extrapolation and interpolation. Okay, so we have 28,500 if this was spent on advertising, which means where there is x, we're going to replace with 28,500. Okay, so this is going to be what's happening here. Okay, so we said we're going to have y is equal 1730,22 plus 13,96 times 28,500. Okay, you just need to put this in the calculator once and for all. And then we're getting our y value as a 39,590,22. So this is how much will be expected when this 28,500 is invested. Okay, then 1.1.3, write down the correlation coefficient of the data. So when you press the shift and 1, you go back to the steps that we got, and then you look for the R. And then you press the equal sign after pressing the R, or after pressing the number that corresponds with R, whether it's 1, 2, or 3, depending on the calculator type that you are using. So from my calculator, I'm getting R to be 0.98002, but 2 decimals, remember. So that's our R. And then they're asking us to describe the association between the amount spent on advertising and the cells. So when they talk of the association, they're asking for the relationship based on the correlation coefficient. Okay, so our correlation coefficient is a positive 0.98. So we're gonna say that the relationship is very strong, but also positive. Okay, I'm saying a very strong positive relationship. Sometimes we say correlation. Okay, so it's very strong because remember we have categories. When it's between 0.8 to 1, that is very strong. Between 0.6 and 8, 1 right. Okay, 0.8 to 1. I might categorize that as very strong, depending on the type of data. Sometimes you can start from 0.95 up to 1 to be high, to be very strong. And then for strong, it's between 0.6, maybe up to 0.79. Okay. Then moderate is between 0.4 to 0.59. And then weak can be 0.2 and so on and so forth. Okay. So that is that. Then the next question is asking us that if we have the profit that the small company made over the same 9 years as given in the table. Okay, so the first part is representing the regression data. Okay, and then the second part is representing more like a variable kind of data where we have just one piece of data that is being get, which is just a profit. Okay, then they want us to calculate the mean. So this one, the same story. just get your calculator into the mode format of the start. So press mode, okay, and then start, and then you can talk about the first set of data. Okay, so in this case, when I put my data, which is the single variable, I only have one column of X and maybe then the frequency. So ignore the frequency part, just enter these numbers into the calculator. So 10750, 107, that, and so on and so forth. When you're done entering that data, with the frequencies, leave them as 1, not change anything. Then we're gonna press again, clear all of the on button. Then we're gonna press your shift 1, and then follow the steps again. Okay. So all I need is the mean. So the mean is usually represented by that symbol. Sometimes something like that in the calculator. So the mean I'm having is 172466.11. Okay. 1624. Oops. What's going on? Okay, so saying the mean is 172466.11 from the calculator. You get 2 marks for that. And then 1.2.2. They want us to get the standard deviation. Okay, that's what the question is asking for. Write down the standard deviation. So from the shift 1, we must look for the standard deviation. It's normally by number 3. Okay. So from my calculator, my standard deviation is 56950. Okay. Just gonna close this for now. Let me just close this before we continue. Okay, so we got our mean. So we're saying we got our mean as and what was the value? It was 172466.11. And then we said the standard deviation is 56950.09. Okay, so these are the two answers for 1.2.1 and 1.2.2. Then 1.2.3, they want us to determine the number of years in which the company made a profit that was greater than 1 standard deviation above the mean. Okay, so when they talk of 1 standard deviation above the mean, it's the same as getting the mean plus 1 standard deviation. Now we know that our mean is 172466.11. I'm going to add the 56950.09. Okay. So when I do the maths, 172466.11 plus the 56950.09, I'm getting 22. Okay, 9416.20. Now the question is asking us, how many years did the company make profit that was greater than what we have? In other words, in how many years do we have profit that is greater than this? So go back to the data. Let me just make this a bit smaller. Oops. smaller, 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 so that I can see my data nicely. I think that's better. All right, so I need to look for amounts that are slightly bigger than 2 to 9. Okay, this is a no, this is a no, a no. 2 to 9, yes. No, yes, no, no, no. So which means we have just 2 years. So the company that much of profit for 2 years. That is the question. That's the answer. And what was expected of us, okay? That is 1.2.3. That's the whole of question on 12 marks. Then question number 2. Question number 2, please don't rush, okay? The ages of the people who attended the music concert were summarized. Okay, this is like group data. So these are the groups or the ages. That for ages between 15 and 5, we have 20 people. And then for ages between 25 and above 15, and then 25 and so on and so forth. So this is the information we have. Then the question is asking us to determine the modal class of the data. So mod, remember, modal comes from the word mod. And you know that mod is the data that appears the most. So when they talk of a modal class, they want us to get a class that is having the highest representation or the highest frequency, because now this is our frequency. And so when I look at all this, I feel like 90 is the biggest representation. So we're gonna have 35 is less x is less or equal to 45. And that would be our 2.1. Okay, then 2.2. They want us to get how many people attended the music concert. So all we need to do is just add up all those numbers. Okay. So I'm just gonna add up those numbers very fast. So we say this is 35 is less x less or equal to 45. So I'm gonna add that. So I have a 20 plus a 25 plus a 60 plus a 90 plus a 55 plus a 40 plus a 30. Okay. And the total that I'm ending up with is 320. So these are the number of people that attended that concert. All right, and then 2.3, they want us to draw a cumulative frequency graph. Sometimes we call this the OGI, okay, to represent the data. Okay, so one thing we need to know that as we are plotting the OGI or the OG, we need to know what we plot and what we don't plot. So since the grid just has everything that we need, we have the cumulative frequencies here, and then we have our edges this side. So these edges are more like the classes, but from the information, we don't have the cumulative frequency. So we need to create some sort of a color for the cumulative frequency. Okay? Because the cumulative frequency that we use when we are plotting a cumulative graph, we don't use the frequency. And how does the frequency of the cumulative go about? So the first frequency will represent the first cumulative frequency. And then for me to get the next cumulative, I'll just plus this 20 plus a 25. I'll get a 45. And then 45 plus 60, I'll get 105. And then 105 plus 90, I'm gonna get 195. Then 195 plus 55, I'm gonna get 250. 250 plus 40, I'm gonna get 290. Then 290 plus 30, I'm gonna get a 320. So the last cumulative must always correspond with the total number of participants or your total frequency, okay, which is correct now. So when I'm plotting my cumulative, this 20, I'm going to plot it with a mean of 5. Okay. Then, no, that's not true. So I'm saying with the cumulative, I'm going to use the upper class boundaries. Okay. So I'm going to plot 75 with 320, plot 65 with 290, 55 with that, 45 and that, even this 15 must go with the 20. And then I'll just extend my graph to a 5. Okay. So what I'm going to do, remember we said we have a 20. Let me just put it somewhere. 20, 45, 105. Okay, so we know that the first one is 15, that goes with 20. Just okay, 15 is between 10 and 20, which is like halfway. 15 goes with 20. This is 1, 2, 3, 4, 5, which is 10, 10. So which means it's gonna be somewhere here. Okay, so this is the mark that I have. And then now I go to 25. 25 is gonna go with 45. Let me just make this a bit smaller so that I can see my values nice. So I got 45. So 25 is still in between here. I need a 45. That's a 40. So somewhere in the middle there. No, that's a 40, but it's close, slightly above. Okay. Then I'm going to 35. This is the line of 35. 35, where are you? You're going with 105. 35 with 105, this is 100. So somewhere, okay. And now I need 45. 45 is 195. So just before 200. Slightly before 200. Okay. And then I need 55. We said it's 250. 55 is 250. Just on the line here. Okay, and then we have 290. 265 is 290, just below 300. Okay, and then we have a 320. All right. Then we have a 320 for the last one, which is 75. This is 300, and this must be 320. Okay, so from that, I just need to connect. Okay. Connect that with your freehand. It might not look like an S curve for now. But remember, it's an algebra, so it has to just that. Okay. And then remember, we said this must be connected to 5 and 0. So the starting point is 3. So just connect that to that. Okay, so that's going to represent my algebra. So this is the 5, which is the starting point of minimum transmitter. All right, that is what we had to do. Then they're asking us to use the graph to determine the median. All right, so with the median, since we have 320 people, some people prefer using a half of n plus 1 to get just the position. So that it is a half of 320 plus 1, and then they locate where that is. Okay. So what is a half of 320? Let me first use this approach. It's gonna give me it's my graph for what, but let me just try to let me rejoin this line and see. I'm sorry, guys. It's live. I don't know. Something like that, guys. This must be slightly straight, but somewhere there. So I'm just gonna use a half of n. I can do the same with a half of 320, so it's 0.5 times 320 plus 1. That's gonna give me 160.5. Okay. 160.5 is just the same as 160. So which means I locate 160 on this side. Okay. And then I must follow this line of 160 till I meet up with the graph. So it's where my graph is meeting. And then I'll drop this downwards. Find how many years it is. Okay. So this was 41, 2, 3, 4, 5. So which means every block is representing 2. So that's going to be like 42 years. Okay. So it's saying that's going to be 42 years just from the graph. Then question number 3. Question number 3. Let's make this a little bit smaller. Okay. So with question number 3, we're being told that in the diagram, the equation of AF is y is equal to negative x minus 11. Okay, this is the line AF. B is a point on the x-axis such that this B is a midpoint. The straight line joining A, which is down there. Okay. It's joining A and C. The angles of inclination are that, and the alpha, so angles of inclination are alpha, and then the 63,43 respectively. AF cuts. Where is AF? Okay, it cuts the x-axis at B, and then D is a point such that DE, okay, this line is parallel to AC. That parallel. Okay, so that is all the information we have. First question, they want us to get the value of t. So where is t? T is by point A. Okay, but then since we have the equation of the line onto which t is whatever put, we can just substitute this point into the equation of the line, because if the point is lying on the line, that point must satisfy that equation. So we're going to have y is equal to negative x minus 11. What is the x coordinate? The x is negative 1. So I'm going to say y is equal to negative 1 minus 11. The answer x is negative 10. Okay. So which means my t is negative 10. Then they want me to get the size of alpha. So for me to get alpha, remember alpha is an angle of inclination. From our earlier grades, we say that if we have m, it must be equal to the tan of, let's say, alpha, but the gradient must be equal to the tan of the angle of inclination. So the question wants the value of alpha. So for us to get the angle, we must get the shift tan, the arctan of the gradient. So we need to know what is the gradient of this line. From the equation, y is equal to mx plus c. This is y is equal to negative x minus 11. So our gradient is a negative 1. Okay. So I'm just going to replace that with a negative 1. But since I'm going to end up with a negative answer, because I know that the shift tan of the negative 1 must give me a negative answer, I need to plus 1 so that I end up with a positive answer. Okay. So I'll say shift tan of negative 1 is negative 45. So the negative 45 is just representing this. Negative, but that is a 45 down. And then since angles are on a line, angles on a straight line, I must just plus 180 or subtract from 180. And then I get the answer. So that's negative 45 plus 180. Then I get 135 degrees. So that is my alpha. Then 3.1.3, they want the gradient of AC to the nearest whole number. So AC is this line. Okay. But all we know about this line is just one coordinate, which is P. So we don't have any other coordinate points that we have. So we cannot use the normal change in y over change in x. But all we have is the inclination angle. So we're going to say that the gradient must be equal to the tan of the inclination, which is 63,43. Okay. When I use this, I'm getting 1,999,568 and so on. But they told us we must round it off to the nearest number, nearest integer. Okay, so that is a 2. And then we're done. Then 3.2, they're asking us to get now the equation of AC. Now, since we already have the gradient, and there's this one point A, we can use that. So we're going to use the gradient of 2 and point A, which is negative 1 and negative 10. Remember correctly, yes. So there are 2 ways of doing this. Some people prefer using the mx plus c format, where they substitute the m and these points and get the value of c. So let's see. So where there is x, I'm going to put a negative 1. Where there is y, I'm going to replace with negative 10. So negative 10 is equal to m, which is a 2 times negative 1 plus a c. And I'll move this to that side. Okay. So that's going to be negative 10 plus 2 is equal to c. So my c is negative 8. And that is done. I'll just rewrite it as 2x minus 8. Okay. Alternatively, someone can use y minus y1 is equal to m into x minus x1. So still the same thing. That is y1 and x1. I'll replace these coordinates. It will be y minus 10 is equal to 2 into x minus 1. This is y plus 10. When I open that, I have 2x plus a 2. Then I'll move the 10 that side. It's going to be 2x plus 2 minus 10. So that y is 2x minus 8. So it's just the same equation, but different formats. So you choose whatever will work for you. And then 3.3.1. Okay. So 3.3.1, they want us to get the coordinates of C. Now, since we have the equation, for us to get the coordinates of C, we need to know the coordinates of B first. Then we can apply our midpoint formula. So what I'm going to do, I need to get the coordinates of B. Okay, so I'm saying the coordinates of B. From my equation, y is equal to 2x minus 8. 3 and 1, okay. B is 2, -4. C is 5, -3. And then we have D, which is x and 0. Question 1.1. They want us to get the gradient of AC. So you're gonna say gradient is normally represented by a small letter m of AC, is the change in y, okay, over change in x, which is the same as y2 minus y1 over x2 minus x1, regardless of how you label this or how you use it. So I'm looking at AC, okay? If this is my x1 and y1, my x2 and y2, then I'm gonna have -3 minus my y1, which is 1, over 5 minus -3. Okay, so that's gonna give me a -4 over, this is gonna be 8. Because negative is gonna be a plus. So which means my answer becomes 1 over 2, but negative. So they're saying the gradient of AC is -1 over 2. All right, so then 1.2. 1.2, that's -3 minus 1 over 5. Okay. 1.2, they want us to get the equation of AC. We need to find the equation of the line AC. So I normally prefer using y minus y1 is equal to m into x minus x1. You could use mx plus c, no problem. So let me use the coordinates of A so that I have my y minus 1 is equal to my gradient, which is -1/2 into x minus -3. Okay, so it's y minus 1 is equal to -1/2 of x. When I open that, I'm going to have -3 over 2. Since this negative and negative will be a plus, and then this negative there. Then I'll move the -1 that side. So my y is going to be -1/2 x minus 3 over 2 plus 1. When we simplify that, what we get? -1/2 x is saying -3 over 2 plus 1, which is -1/2. That is -1/2. Oh Lord, what's happening? What is going on? Sorry about that, guys. Okay, so we're saying it's gonna be -1/2. So that becomes the equation of the line that they want. Then 1.3, they're asking for the inclination. Okay, so one thing we know about the inclination is basically the angle that the line AC makes with the x-axis. Now I prefer the positive angle. So from m is equal to the tan of theta, okay? So if I was to call this my theta, just as my angle of inclination, for me to get that angle theta, I'll use the shift tan of m, okay? Where m is the gradient of that line. So since we got that gradient from 1.1 as -1/2, I'm just gonna punch that into my calculator and say my theta is gonna be the arctan of -1/2, okay? The arctan of -1/2. All right, and I'm getting -26.57 degrees. But remember what we said, we are interested in having a positive angle. So what we normally do, if we have a negative angle, just add 180. Or you could get a half and then you subtract 180 minus, you can simplify that. Okay, so if I have negative 26,57, I'm adding 180 degrees. I'm ending up with 153,43 degrees. Okay, so which means this is 153,4 degrees. This angle here, 153,43 degrees. Okay, so that is our angle of inclination. That is done. Then 1.4, they want us to get the coordinates or determine the coordinates of D if AC is a perpendicular bisector. So we have two words here. Number one, we have the word perpendicular. And then the other word is the bisector. Okay. So if AC is a perpendicular bisector of BD, which means this side is the same as this side, and M becomes the midpoint. Okay. If that is true, how do we get the coordinates of D? We need the coordinates of M. Nope, we don't need them. I'm gonna look at the gradient format where, let's say, if I get the gradient of BD times the gradient of AC, this must give me -1 according to the gradients of perpendicular lines. Okay, remember perpendicular simply means the lines are meeting or crossing each other at 90 degrees. So I think I can use that and say that the gradient of BD, okay, times the gradient of AC, I must end up with a -1. Let me just put it aside. Gradient of BD times the gradient of AC gives me -1. So since I know that the coordinates of B and D will be x0 and 2, -4, I can still apply my change in Y for BD. And then this is, I already have the gradient of AC, so I'll just replace it as -1/2. It must give me -1. Okay. So I'm gonna let my, I don't know, I can let this to be my x2 and then my, why not 1? Either way, doesn't matter. I'll call this 1 and then y1. And this is gonna be my x2 and then my y2. Okay. Then when I substitute in the gradient formula, I'm gonna have -4 minus 0 over 2 minus x. Okay, I'm multiplying this by -1/2 is equal to -1. Then I can divide both sides by -1/2. Okay, so that I have just -4 over 2 minus x is equal to just the 2. Guys, just confirm that for me. It's a 2. That's correct. Then from there, I could cross multiply so that I have -4 is equal to 2 into 2 minus x. I'll open up the brackets. My -4 is equal to 4 minus 2x. I can move the 4 that side. -4 minus 4 is equal to -2x. So -4 minus 4 will give me -8 is equal to -2x. Divide both sides by -2x, sorry, by -2. And then my answer is a 4. So which means that, okay, so we're saying x becomes 4. So which means the coordinates at point B are basically 4 and 0. Coordinates at D will be 4 and 0. All right. Then 1.5, they're telling us hence deduce that A, B, C, D height. So the question is not asking us what kind of shape it is. They're already telling us that indeed this quadrilateral is a kite. How do we deduce that? Now we know that from the properties of a kite that the diagonals, because it has this diagonal and this diagonal, that bisect at 90 degrees. But the question has already told us that, okay, that those ones are diagonal, or those diagonals are perpendicular to each other. So we can't use that kind of aspect. Okay, we cannot use that. The other property that we know about the kites is that the adjacent sides will always be equal to each other. So let's say AD is the same as AD, and then BC is the same as CD. I feel like I'm going to use that approach to deduce that ABCD is a kite. Okay, so I'll start by determining the distance AB. Okay, and then from my distance formula, I know that x2 minus x1 squared minus y1 squared. And it's gonna kind of be lengthy, but I'll have to do it. Okay, when I do my substitution, okay, that's going to be -3 minus a 4 squared plus 1 minus 0 squared. When I punch that into my calculator, I'm getting 5√2 units. Okay, so if that is 5. Okay, guys, so now let's look at AD. Was that AD? Was that AD? Yes, that was AD, not AB. Okay, sorry about that. That's AD. And let's look at the AB. So it's going to be more or less the same thing. So I'm going to look at -3 and 1, and then 2 and -4. When I substitute into the distance formula, I'm going to have -3 minus 2 squared plus 1 minus 4 squared. Okay. When I punch that into my calculator, I'm having, that's a 5, and that's also a 5. All right, so I'm also getting 5√2. Then I'll go down and find the distance for CD. I have 4, 0, and 5, -3. Okay, so my CD, substitute that into the calculator, it's going to be 5 minus 4 squared plus -3 minus 0 squared. I punch that, I'm having just the √10. And then lastly, I need my distance BC. So with BC, I'm looking at 2, -4, and then 5, -3. Substitute that into the distance formula. So that's gonna be 5 minus 2 squared plus -3 minus 4 squared. I'll substitute that, punch that in the calculator, 5 minus 2 squared plus, I'm saying -3 minus 4 squared, which also gives me √10. Then come down and say that since AB is the same as AD, and then CD is the same as BC, therefore ABCD is a kite. And the reason is adjacent sides. Okay, we are saying adjacent sides are equal. All right, so there we go. Adjacent sides are equal. So guys, that is question 1.5. Let's look at 1.6. They want us to calculate the area of ABD. Sorry, yeah. Area of ABD. So if we look at this, this is our point of focus. Okay. So since they told us that there was a perpendicular bisector, so we have a 90, which means AM is our height. Okay. I'm saying our height is going to be AM. And we also need to get the distance of AM. So we shall need the coordinates of AM finally. Then we need to get the distance BD. Yeah. Let's get the distance BD, then get the distance AM. Then we shall be good to go. So what I'm going to do, I'm going to start by finding the coordinates of M. Okay. So coordinates of M, we say this is 1.6. 1.6 coordinates of A using our midpoint. Okay. Midpoint formula, where we know that for the midpoint, we have x1 plus x2 divided by 2. Then do the same thing with the y. y1 and y2 divided by 2. So I'm going to focus mainly on the coordinates of B and D, with my x1 and y1 and things like that. So which means my coordinates of M are going to be 2 plus 4 divided by 2. And then for the y, it's going to be 0, AM. Need to get the length AM. So if M, let me just say if A is -3 and 1, this is our aim. So the distance, I'm gonna say x1 minus x2 squared from the distance formula, y1 minus y2 squared. Okay, you have the right to label this as x1 and x2 in whichever format you're comfortable with. So that's gonna be 3 minus -3 squared, plus with the y, I'll have -2 minus 1 squared. And I substitute that into the calculator. I'm gonna have 6 squared plus 9, which is 3.5. Okay, that is our height, the distance AM. Then I also need to get the distance BD. Okay, so with BD, remember the coordinates of B are -2, sorry, are 2 and -4, and then D is 4 and 0. So what I'll do, I'll just say 2 minus 4 squared plus -4 minus 0 squared. Punch this into the machine. Okay, so that is 2 minus 4 squared plus -4 minus 0 squared. That is giving me 2√5. Okay, but since ABD is a triangle, I know that the area of a triangle will be given as a half times the base times the height. So our base is the BD, and then our height is the AA, as initially stated. So when I substitute, it's going to be a half times 3 root 5, and then multiplied by 2 root 5. Okay. When I simplify that, that is 6. So 3 times 5, which is 15. I don't know, comrades, what you get in that side. So this is 15, but units squared. So that becomes our area for that particular triangle. So guys, that's what you have to do for question number 1. Okay, we move on to question number 2. They are telling us that in the diagram below, we have Q, which is 15, and M is the center of a larger circle, which touches both the x-axis and then the circle that is centered P. The circle with P has the y-intercept at A. Okay, we can see that. And it has an equation of this much. All right. If that is true, they want us to determine the equation of the circle with center Q in terms of x, y, and m. 1 mark. So guys, we know that the general equation of a circle is x minus a squared, and then y minus b squared is equal to r squared. Remember, the minus can be a plus, depending on the coordinates. Now, what I'm going to do, I'm just going to say x, since the 15 is positive, I'll change the sign. I'll say x minus 15 squared plus y minus m squared is equal to what is our radius? Our radius 8 units. So 8 squared is a 64. So that is 2.1.1. Then determine the value of m. 2 marks. Value of m. All right, so there was a statement that was given to us. Number 1, they told us that the larger circle touches the x-axis. That is important. Then they told us that the radius of the circle is 8 units. So if this is 8, which means even if I try to drop a line, okay, that is parallel to the y-axis, the distance there is going to be 8. And remember, the x-axis is also named as y is equal to 0. So which means we are counting how many units from the 0 line? 8 units to the center. So which means m is automatically 8 units. Okay, so saying m is going to be 8. Then if that is true, then they want us to get the length of PQ. PQ. When I look at the equation of circle P, the coordinates are 3 and 5, not 3 and 3. Okay. But the radius is 5. Since r squared is 25, which means the radius is 5. So which means from here up to there is 5 units. But we said from the circumference to the center of the big circle is 8. So guys, we don't need to find, or we don't need to use the distance formula in this case. We can just plus the radii. So 5 plus 8, and then that gives us 13 units. Okay, so if you have trust issues, we could probably use the distance formula just to affirm or confirm that indeed what we're talking about is correct. Okay, you get your 13 units there. Then if that is true, then they want us to get the coordinates of A. Coordinates of A. So since A is the y-intercept of circle P, and we already have the equation of x minus 3 squared plus y minus 3 squared is equal to 25. One thing we know about the y-axis is that x is always a 0. Okay, so what I'm gonna do, I'm gonna get that equation of that circle, x minus 3 squared plus y minus 3 squared. Okay, so that's a 16. And then I'll find the square roots on either sides. Okay, so y minus 3 will give me a plus or minus 4. Okay, I don't want to go that route of opening up, but you're still allowed to do that. You find the quadratic, and then you get your two values using the quadratic formula or the factors. Okay, so my y is going to be plus minus 4 plus a 3. So the first y is either 4 plus 3, which is a 7, or negative 4 plus 3, which is negative 1. Now, the question wants the coordinates. It wants the coordinates of A. So since we have two values, you can see that this smaller circle is meeting the y-axis at 2 points. Okay, so now we need to choose selectively, or we need to be very logical. Okay, so I'm going to say that my A is going to be 0 and 7. Since 7 is on the positive side. Okay, that is done. Then 2.1.5, they want us to determine the equation of a tangent to the circle with center P at point A. So one thing we know about a tangent is a line that touches the circle, that touches any graph at one point. And from our circle geometry, we know that the radius or diameter and the tangent will always be perpendicular. So since we have our coordinates of A, which is 0 and 7, we can get the gradient of PA. Okay, so we're saying gradient of PA. This is question number 2.1.5. 2.1.5. So gradient of PA, that's going to be change in Y over change in X. So when I look at my coordinates, so I'm gonna have 7 minus, okay, so 7 minus 3 over 0 minus 3. Okay, so 7 minus 3 over 0 minus 3, that's gonna give me a negative 4 over 3. This is the gradient of the radius, okay? But the radius and the tangent, we said will be perpendicular, which means the gradient of the tangent is going to be 3 over 4. Remember what we said about perpendicular lines, that M1 times M2 must give us negative 1. So I'm just dividing negative 1 with this, give me 3 over 4. Then I'm gonna say at A, which is 0 and 7. So my y is gonna be 3 over 4x plus a 7. I don't need to use that formula since I know that this A is also acting as the y-intercept of my tangent. Okay, guys, so that is 2.1.5. All right, then 2.2. 2.2, they're telling us that two other circles are drawn or are given. Okay, one circle has a center K with this equation. The other has a center T, but with this equation as well. Determine the center and the radius of a circle with center K. And so what we normally do is we complete squares in this case. Okay, so I don't know how one would approach this, but I would always prefer moving the 12 that side. So I'll have x squared minus 6x plus y squared plus 4y is equal to 12. Okay, then Let me just write it this side. This is 2.2.1. Okay, we said x squared minus 6x plus y squared, okay, plus 4y is equal to 12. Okay, guys, so we're gonna open two brackets. Okay. Just watch what I'm gonna do now. Okay, so we're gonna get x, and then let's keep the sign to minus, and then we get a half of 6, which is a 3. We square that. Okay, we know that 3 squared is gonna give us a 9. So we're gonna plus a 9 somewhere here. Then let's go to the y. Let's keep the sign, which is a plus. Then a half of 4 is 2. We square that. So we know 2 squared is 4. So I'm gonna put it that side, plus 4 as well. So which means I'm having x minus 3 squared plus y plus 2 squared is equal to 12 plus 9 plus 4. Is that true? Yes, which is a 25. So which means the coordinates of k are gonna be 3 and negative 2. I need to switch the signs inside the brackets. And then my radius will be the square root of this 25, which is 5 units. Okay, so guys, that is that, because this whole thing represents the r squared. So square root will be 5 units. So 2.2.1 has been answered. Then 2.1.2, sorry, 2.2.2. So we said this is 3 negative 2, and then our r is a 5. Then they want us to get the distance between the centers, K and T. The distance between the centers. Are these circles touching each other? No, we don't know. We don't know for sure. So we know that the coordinates of T are 12 and 10. And we know that the radius of the circle T radius is going to be 10 units. Ne? So what we need to know, use the distance formula so that we just save time. So KT is going to be the square root. I'm going to say 12 minus 3 squared plus 10 minus 2 squared. I'll punch that into the calculator. This is 12 minus 3. Come on. 12 minus 3 squared plus, that's 10 minus 2, which is a plus 2. And I square that, I'm getting 15 units. Okay. So answer for 2.2.2 is 15 units. That's from the distance formula. Now, they're asking us at how many points do the two circles intersect? So guys, remember, if you have two circles that are having K and T, if we get the distance KT, if this distance is equal to the radius of K plus the radius of T, then this is going to be just touching at one point. Then if our KT, the distance we just found out, is greater than the radius, the distance of the radii, then which means they are not touching. Okay. And then if our KT is smaller than the radii, which means the circles are touching at 2 points. Okay, so we have our KT. Can we get the radius of K plus the radius of T? Remember we said radius of K was a 5, radius of T is a 10. So that is 15. So the two are equal. And we said for as long as they are equal, the circles are touching at 1 point. Therefore, circles touch at one point. Okay, so at how many points do they touch? So we said 1 point. The motivation is going to be this. KT is equal to RK plus RT. There we go. So that would be our motivation, and that would be question number 2. Question number 3. This is Trig. All right. Why are there a lot of marks? 24 marks up for grabs. Okay. Let's see if we can have them. Let's see if we can have these marks. All right. So I'm going to just erase this. Okay. Question number 3. Question number 3, they're telling us that we need to simplify without using any calculator. Simplify without using any calculator. So what I'm seeing is a big expression. The expression is sine squared, okay, of 360 minus x, minus I'm having the cos of x minus 180 times the tan of negative x. And then I'm multiplying that by the sine of 90 minus x. And then this must be multiplied by the cos of 360 plus x. All this is being divided by the sine of 180 plus x. So guys, we need to apply our reduction formulas or reduction ratios within this question of 3.1. So what I'm seeing is that 360 minus x, maybe before we even start working out this, remember from our Cartesian, okay, we said we measure angles in the anti-clockwise direction. Those will be positive angles. And this quadrant is normally known as 90 minus theta. I will normally call it 360 plus theta or x. Then this is 90 plus theta, or sometimes we call it 180 minus theta. This quadrant is 180 plus theta. And then this quadrant is known as 360 minus theta. Remember that in the trig ratios here are all positive. It's only the sine, only the tan, and only the cos. Okay. Now, when you look at 360 minus x, in which quadrant we find 360 minus the reference angle? It's in quadrant number 4. So in quadrant number 4, the only trig ratio that is positive is cos, which means sine is going to be negative. So I'm going to have negative sine x, but then I'm squaring that. Minus, I go to the top part. So we know that the cos of x minus 180 is just the same as the cos of 180 minus x, just for the cos. For sine and tan, we need to factorize out the negative sign, but for cos, it doesn't matter. So 180 minus is in quadrant number 2. And in quadrant number 2, it's only the sign that is positive. So that's going to reduce to negative cos x. Okay. Then I move on to, I can put this in brackets. I go to the next one, the tan of negative x. I can take the negative out so that it's negative tan x. And then the sine of 90 minus, this is a complementary ratio. So this is going to give me a cos of x. And then cos of 360 plus, remember 360 plus is in quadrant 1. And in this quadrant, all the trig ratios are positive. So that's going to be cos x. When I divide by cos 180 plus is in quadrant number 3. So in this quadrant, it's only tan that is positive. So this is going to reduce to a negative sign. Okay, if that is true, then what do I see? I'm seeing that this is going to reduce to just a positive sine squared x. Okay, minus, I can change this to sine over cos if I want, but yes, I want. So then I'm still gonna keep that negative sign there, but I know that this negative and the negative will give me a positive. So cos x times sine x over cos x. And then I'm multiplying this and that. Let me just call it cos squared x and dividing it by the sine of x, negative. Okay, then I'm seeing that I have common things. This can cancel that. This negative and negative can give us a positive, no problem, but this sign can also cancel that sign. It's not a problem. So I have sine squared x. We said negative and negative will give us a positive, and then that's going to be cos squared x. From our identities, we know that sine squared plus cos squared, we must get a 1. Therefore, our answer is a 1. That is 3.1. And that's how you get all the 8 marks. Now, remember, marks will be awarded usually to the reductions that you do. Okay, let's say for a negative course, you could get a mark. For this course, a mark. That would be a mark. This would also be a mark. These are already 4 marks. You could get probably a mark for the positive sine squared. Those are 5 marks, 3 marks to go. The expansion of sine over cos could also be another mark. Those are 6. The simplification here, we can make this a 7, and then the last answer could be the 8 marks. Then let's look at 3.2. Another mega question, 3.2. They are telling us that if beta is between negative 90 and 270. So remember, we said angles are measured to be positive in the anti-clockwise direction. Then if we follow the clockwise, then those will be negative angles. So if this is a 0, this is going to be negative 90. So in other words, we're looking at angles from this region, that same region. Okay, those are the angles we're focusing on for beta. So without a calculator, they want us to simplify this. Okay, so still we're going to apply our reductions, because this is a 45, this is a 405, a 300, and so on. But then in this case, we might need to use what we call the special angles. Okay. So what I'm going to see, I'm going to expand this, or I'll take out the negative first so that I'm just remaining with the sine 300. Cos 45 is just fine in this format. Then I need to see where I find this, and all right. So I'll have something like cos of beta plus 80 is equal to negative sine 300 times the cos of 45. And then I'm dividing this by the cos of 405. Now, when I apply my reductions, the question would be, where do I find 300 on Cartesian? So 300 is after 270, which means it's within quadrant number 4, where my reference or my reductions must be 369 or something. So that's going to be 360 minus an angle, give me 300 to be 60 degrees. Cos 45, we said we leave in it the way it is. And then where do we find 405? That is after 360, so probably in quadrant number 1. So that's going to be 360 plus, is it a 45? Yes. So 360 plus 45 must give me this. This is equal to the cos of beta plus 80. All right. Then I'll go down and say my cos beta plus 80 is equal to, I can reduce this. I know that 360 minus in the 4th quadrant, sine is negative, okay? So that's going to be negative and then negative sine of 60. Cos of 45 is going to stay the same. And then in the first quadrant, when I reduce this, I'll get a cos of 45. All right. Then, I don't know whether I'm making sense, but we move. So this is going to cancel that. This negative and negative, I'll get a positive sine 60. So I'll have the cos of beta plus 80. It's going to give me, what is it giving me? It's giving me the sine of 60. Remember, we don't have to use any calculators. Sine of 60, which is fine. Then, at this point, I need to find a way of expressing either cos in form of sine or sine in form of cos, whichever one would make sense for you. So I'll just replace this. So this is going to be a cos of beta plus 80. If I use the co-ratios for the complementary angles, I can use 90 minus 30 will give me 60. And then if I apply my cos, okay, so that's a cos of 90 minus 30. Does that make sense? No. Not at all, not at all, not at all. It can't be a 30. It has to be a 60. Okay, so that I can end up with a sine of 60. Okay, so then if that is true and I have the same ratios, cos and cos, which means I can just drop them. And I have beta plus 80 is equal to 90 minus 60. We know that is a 30. And then move the 80 that side. So that my beta is 30 minus 80, which is negative 50. Okay, so where do I find negative 50? Negative 50 is most likely to be found in this quadrant here. Is there any other quadrant that's going to give me an answer within this range? Okay, I believe there is no other quadrant. So I'll leave it at that, guys. 7 marks. I don't know, but I feel like I've done what is enough for 7 marks. Because we expanded this, we reduced it, then we introduced the co-ratios, and yeah. Guys, if there's any other approach or any other value of beta, please advise me. I'm moving on to 3.3. Determine the following, or the value of the following, still without a calculator. So still we can use our reductions in this case. This is sine 49, this is 41. When I look at 49 and 41, it gives me 90. I'm gonna use the complementary. So I can get the sine of 90 minus 41. Because 90 minus 41 gives me 49. Okay, I'm gonna divide it by the cos of 41. So guys, in this case, do not change both, just change one of them. So it's gonna make life much more easier. Okay, when I simplify the top part or when I reduce the top part, the cos sign. So this is a double angle, but it's a double angle of, not a double angle, it's a compound angle, sorry. It's a compound angle of sine. So if I call this my A, and then I call that my B, so I can reduce this to the sine of 85 plus 65. Okay, and I reduce this, simplify what is 85 plus 65, not times, plus, I'm getting 150. Okay, that's sine 150. Then we know that 150 can be found in quadrant number 2, where we have 180 minus. Okay. So sine of 150, this is question number 3.3.1, is the same as the sine of 180, which angle do I subtract from 180 to 150? It's going to be a 30. So this will reduce to just a positive sine 30 because we said in quadrant number 2, in this quadrant, sine is positive. Now from our special angles and special triangles, the sine of 30 is going to be a half. Remember this equilateral triangle, 2 and 2. Say divide that into 1 and 1. That's a 60, that is a 60. We've divided the 60, now it's a 30. Okay, so this is a 1, this is a 2. When you talk of sine, it's the opposite of the hypotenuse. Okay, so that is 3.3.1. No, that is 3.3.2. This was the problem. I'm tired as early as this. Okay, 3.3.3. A half cos 15 plus root 3 sine 15. Guys, this question needs some bit of thinking. We need big guns for this one. So it's a half cos of 15 plus root 3 sine of 15. Okay, what I'm gonna do, I'm just gonna open this up so that I have a half the cos of 15 plus root 3 over 2 the sine of 15. I'm gonna take my chances and see if I'm gonna get something. So guys, when I look at my trig ratios, which angle from our special triangles is going to give us root 3 over 2, and it's going to give us a half. Root 3 over 2, and it's also going to give us a half. Okay, so remember from this big triangle again, we're calling this a root 3. Okay, if this is a root 3, I know that root 3 over 2, which must also be the same as a half. If I use, let's say, the cos of 60, it's going to be 1 over 2. Okay, and then when I look at the sine of 60, it's going to give me root 3 over 2. So I'm going to use this triangle and I'm going to use this ratio. So where I see a half, I'm going to replace with this. Where I see root 3 over 2, I'm going to replace it with that. So this is going to be cos of 60 and then cos 15 plus this we said it's a sine of 60 and then the sine of 15. Boom. Then I have my compound angle. It's a cos cos, sine sine. So this is a compound angle of cos. So if I call this my A and my B, remember the sign here is a plus, which means it has to be a difference. Okay, so this is going to be the same as the cos of 60 minus 15. This becomes cos 45. And from our special angles again, is that triangle that talks about 1, 1, and then 2. That's a 45, and this is a 45. That's a 90. So cos of 45 becomes 1 over root 2. Use a calculator, you get root 2 over 2. And that would be using a calculator. Question said without. All right, so that is question number 3, guys. Let's move on to question number 4. Question number 4, they want us to determine the general solution. Okay, determine the general solution of this. Hey, gonna be trouble now. Yeah? He's saying the cos of 54 minus x is equal to the sine of 2x. If I expand this into 2 sine x cos x, it's gonna cause more troubles for me. I could do that, but I can find a simpler way of doing it without really causing any harm, or without going through paragraphs and pages of answers. So like we answered, there's a question that we answered where we changed, where we swapped the ratios and made them the same. Which question was that? Yeah, it was 3.2. You see this at this point where we changed this to just the same kind of ratio. It's the same thing I'm going to apply here for for question 4.1. And so what I can say is that when I look at cos, I think I can write a cos in terms of sine using the 90. Okay, so I'm going to say if I have sine of 90 minus the 54 minus x. Okay, because sine does not discriminate the signs. It's going to be the same as sine 2x. Okay. If I simplify this by opening what is in the brackets, I'm going to have 90 minus 54 plus x is equal to my sine of 2x. And I simplify this 90 minus 54 from my calculator, I'm having a 36. So that's going to be sine of 36. Why am I saying 360? Go for rotation. Okay, 36 plus x is equal to the sine of 2x. Now, since the ratios are the same, there are two things I just want us to keep in mind. Number one, I'm going to take this sine 2x, okay, to be more like my reference angle. Okay, let me do that, then I'll explain what I want to do. So 36 plus x is equal to the 2x. Okay. Then what I'm going to do, I'm going to take this to be positive, yeah? And then I'm going to solve for x in this case. Does that make sense? Which means I'm going to move the x this side so that my x is equal to 36 plus my k times 360. K is an element of integers. Okay, these are degrees. This is going to be my first solution. So what I'm saying, I'm taking this 2x to be my reference angle, which means this is quadrant number 1, where our sign is positive. Then in quadrant number 2, because that's where I find my sign to be also positive, I'm going to have 36 plus x is equal to, I'm going to have 180 minus 2x, and then plus k times 360. I'm just writing the solution. Just from here, if this is my reference angle, then I'll have my 180 minus theta in quadrant number 2, where my theta is 2x. I can't use 36. Can I use it? I can, no problem. I can use 36, but it's going to cause me troubles. So I would rather stick to the 2x here. Then I need to isolate everything. So I'm going to move the 2x this side. I'm going to move the 36 that side. So it's going to be x plus 2x is equal to 180 minus 36 plus k times 360. Now remember, when you're doing addition, switching, or subtraction, it's only the reference angle that is affected. This other element is not affected with addition and subtraction. So this is going to be 3x is equal to 180 minus 36. I'm ending up with 144. And then I'm plusing k times 360, and then I can divide through by x by 3, not by x. Okay, so divide by 3 by 3, and now the division affects that last part. So x is equal to 144 divided by 3 is I'm getting 48. plus k times 120. K is an element of integers. So guys, that's my first solution. And then that was also my other solution. So that's how I would have approached question 4.1. Okay, because it's not a usual general solution question, but it happens. Ne? It's not in the normal, it's a new normal. All right, 4.2. 4.2, they're telling us that if 13 sine of x plus 5 is equal to 0, where our x is between 0 and 270, determine without using the calculator the value of sine 2x. So in this case, normally they will tell you with the aid of a diagram. Okay, in this case, they never said that, but it's 5 months. So guys, without a calculator, so don't be tempted to find the value of x using the arc sign and what. It's going to cause trouble. So with such questions, we are advising you to draw up a sketch. Okay, so 13 sine x, they said plus 5 is equal to 0. So step number 1, isolate this trig ratio. Move the 5 that side so that I have sine x is equal to negative 5 over 13. Move the 5 and then divide by 13. So if that is true, remember they're telling us that our x must be between 0 and 270. So when you're drawing your sketch, we need to also align it in the correct quadrant. So they said between quadrant 1, quadrant 2, and quadrant number 3. So from our simplified ratio, we see that the sign is negative. So this sign just helps us in identifying the quadrant. So we know that in quadrant 1, sign is positive. Quadrant 2, sign is positive. So the only quadrant that is left to focus on is quadrant number 3, where the sign is negative. Okay, so I'll draw my triangle in this sort of format. Remember, the height of the triangle must always be to the x-axis. You can never have it this side of the y-axis, always towards the x. Then I can replace my values. Remember, we said sign is opposite. Okay, opposite, this is the opposite, which is the negative 5. Our hypotenuse, here it is the 13. And then this distance, you need to find it using the theorem of Pythagoras. So r squared is equal to x squared plus y squared. We're looking for x. So which means it's going to be the square root of 13 squared minus 5 squared. Okay, so square root of 169 minus 25, which is a 12. Now, when you look at the square root of any answer, we always tell you it's a plus or minus 12. Now, this is where it plays out. When you look at this distance or this length, it's on the negative side of the x. So we shall label it as negative 12. And then this whole angle will be x, or even just this part inside alone. Now, this is our sketch or our diagram that we're going to use to answer the question that they need. Question is asking us to find the sine of 2x. So we know that sine 2x can be simplified as 2 sine x cos x. That's an identity. Then we're going to say 2 times. We know that the sine of x is this. So negative 5 over 13. Cos of x, we need to get it from here. So the cos is adjacent over hypotenuse. And that thing of written. So adjacent over, so that's negative 12 over the 13. When you look at this, just simplify the numerators. This is 2 times 5 is 10. 10 times 12, that's going to be 120 over 13 and 13. That's going to be 169. Is it possible to simplify that? Not really. Just leave it like that. Now the question is 5 minutes. Some marks are going to be awarded just for using the correct sketch, the correct diagram. This answer of yours might just carry probably 2 to 3 marks. but some marks are going to be allocated. Then 4.3, they want us to prove the identity. 1 plus sine 2x over cos 2x is equal to this, 7 marks. Wow. I don't know. Looks, the marks are scary. Eh? Feels like, no, it's a huge question. Let's see. Let's hope we get the answer. Because such questions are a headache. Eh? You're given the question, and then you're also given the answer. So if you fail to get it, you know that, oh, those marks are gone. So in this case, remember, when you're proving such questions, it's your choice to start with any side and move towards the other side. So I'm gonna start from the right-hand side. I don't know, for this particular question, because I see this, I feel it will be much more easier to work with this and move towards the left-hand side. So I'm gonna say my right-hand side, I have cos x plus the sine x over cos x minus sine x. So what I'm going to do, I'm going to multiply by the opposite of this. So I'll say cos x plus sine x over cos x plus sine x. Now, the reason as to why I'm using the same bracket is because if I cancel it, I'm going back to the original thing. So I'm introducing something just to help me out in simplifying the question. Okay, so that is in brackets. So when I open this up using my FOIL, cos and cos is going to give me cos squared x. Cos and sine, I'm going to get cos x sine x. And then I'm going to have another cos x sine x. And then I'm going to have my sine squared x. At the bottom, one bracket is negative, one bracket is positive. It's more like a difference of two squares. So that is cos squared x minus, okay, let's go. Let me not skip. People will be asking, why are you running? Okay, so cos and cos, that's going to be cos squared x. Cos and sine is going to be plus cos x sine x. And the negative sine and cos is going to be negative sine x cos x. The negative sine and positive sine is going to be negative sine squared x. Okay, now it's time for me to simplify. So from the top part, I can see a cos squared x. So this and this is going to give me 2 sine x cos x, and then I have my sine squared x over, this is going to cancel that. And I'll be left with cos squared x minus sine squared x. Then we know from our identities that cos squared and sine squared must give us a 1. Okay, so that's going to be like 1 plus 2 sine x cos x over, when I simplify this from my formula sheet, I can see that this is another expression of the double angle of cos. So that's going to be cos 2x. When I look at this top part, it's the double angle of sine. Okay, so that's going to be 1 plus sine 2x over cos 2x. There we go. This is equal to the left-hand side. And then I'm done. So that is how I would have gone about with that question. Okay, I'm not going to comment further to say whether it was hard or easy, but that is the approach. Question number 4.4. If sine 39 is equal to P, okay, determine in terms of P, all of this. So still with this question, I don't know, I feel like you can still use a simple sketch if you don't mind. So let's call P to be P over 1. And then this triangle can be right angled. If that is a 39, this is a 90. What angle is that? So what is 90 minus 39? I'm getting a 51. Not a big deal. Sine is opposite over hypotenuse. Okay, so this is our opposite, this is our hypotenuse. So which means this remaining side will be 1 minus p squared from your Pythagoras. Okay. Then 4.4.1, I need to find the sine of 129. So 129 can be found in quadrant number 2. Okay. In quadrant number 2, that's why I have 180 minus theta. So which means I need to express this 180 minus something so that there is an element of a 39 attached to it. Alternatively, if I don't work it that way, we know that in quadrant 2, it's also the same as 90 plus theta. Okay. I don't know which one, but I feel like the 90 can be easier. So that's going to be 90 plus a 39. Okay, 90 plus 39. We know that this is going to reduce to something like cos of 39. When I reduce that, then I can come to my sketch. I know that cos is adjacent over hypotenuse. So the answer must be 1 minus p squared. So that is my answer for 4.4.1. And as much as the question is 3 marks, you could be given a mark for just drawing this sketch and finding the missing sides before you get the answer. Okay. This answer could be a mark, and then other mark could be for the sketch. Then let's go to the turn 321. So 321, 321, 321 is in quadrant number 4. Quadrant number 4 is the same as 360 minus something. Okay, what is 360 minus 321? That's a 39. Okay, 360 minus 39, I'll get my 321. And in quadrant number 4, we know that tan is negative. So this is going to be negative tan 39. And then I'll have to apply the ratios from that triangle. That's a negative. We know that tan is opposite over adjacent. So it's going to be negative p over square root of 1 minus p squared. So that is going to be my answer. Then 4.4.3, sine of 7/8. So how does 7/8, because 7/8 is an acute angle, how does it relate with the 39? Is it a multiple? Is it a vector? I mean, what's going on there? So what I'm seeing is that if I get 2 times 39, I'll get my 78. Okay, so this is a double angle of 39, which is the same as 2 sine 39 and then cos 39. Then I'll go back to my triangle there. That is 2. You know that sine of 39 is a p. And then the cos of 39, we said it's the square root of 1 minus p squared. There we go. So that is what one would have done for question number 4. Question number 5. Question number 5. Okay. So with question 5, they are telling us that in the diagram below, O is the center. Okay, that's a keyword of the circle, and L is a point on the circumference, and then the diameter P.2. This is also relevant. So that's a P.2 diameter, and it makes 26 degrees with a tangent. Okay, we also have a tangent. Good. R, L, M. That's the tangent. Then N is a point on the lower part. Where is N? Oh, here it is. Okay. That is the information. That is the drawing. And they want us to get the size of OLM. So OLM. In other words, they're asking for this angle here that the radius makes with the tangent. Does that make sense? Yes, because we know that OL is radius. Ne? So what angle is that? So what I can say is that OLM is going to be 90 degrees. Okay. OLM is 90 degrees. That is the statement. The reason is going to be tangent is always perpendicular to the radius. Some people call it tan radius. Ne? Tan perpendicular to the radius. Then they want us to get O2. Now, since we've said that this is a 90, then what is this O2 here? So from the triangle LOM, okay, so it will be 90 plus 26 plus O2 must give you 180. Oh, since you know that this is a 90, then these other two must also give you a 90. So it's as good as someone saying 90 minus 26. So our 90 minus 26 is 64. So which means O2 is 64 degrees. You can say angles in triangle OLM or LOL in whichever format. Okay, so that is the explanation. Then they want us to get P. What's happening with P? It's a different. Okay, so P is here, is the angle at the circumference. What we just found was the angle at the center, the 64. So what normally happens that these questions are structured in a way that whatever you get in the previous question must always guide you towards answering what is coming down, okay? So if this is a 64, we can see, okay, I don't know if people can see that the same segment or the same chord that is creating 64 is the same chord that is creating this. Just that O2 is at the center, P is at the circumference. So we apply angles at the center. Must be twice angles at the circumference. So since we have the angle at the center 64, which means P must be a half of 64. So which means P is going to be 32 degrees. The reason angle at the center is equal to twice angle at the circumference. Okay, so that is P, which is a 32. Then they want us to get Q1. Q1. How many marks? Which is 3 marks. Q1, Q1, Q1. Does it make sense? It can make sense. Let's see. Let me change this to a green. Okay, this is the angle that they want. All right, shouldn't be a problem. So I'm going to say from LOQ. Okay, from LOQ. If I focus on this triangle, okay, I know that this side must be the same as this side, which is radii. Okay, so I'm going to say OL is the same as OL is the same as OQ. The reason radii, and if that is okay, so P is here, is the angle at the circumference. What we just found was the angle at the center, the 64. So what normally happens that these questions are structured in a way that whatever you get in the previous question must always guide you towards answering what is coming down, okay? So if this is a 64, we can see, okay, I don't know if people can see that the same segment or the same code that is creating 64 is the same code that is creating this. Just that all 2 is at the center, P is at the circumference. So we apply angles at the center. Must be twice angles at the circumference. So since we have the angle at the center 64, which means P must be a half of 64. So which means P is going to be 32 degrees. The reason angle at the center is equal to twice angle at the circumference. Okay, so that is P, which is a 32. Then they want us to get Q1. Q1. How many marks? Which is 3 marks. Q1, Q1, Q1. Does it make sense? It can make sense. Let's see. Let me change this to a green. Okay, this is the angle that they want. All right, shouldn't be a problem. So I'm going to say from L or Q. Okay, from L or Q. If I focus on this triangle, okay, I know that this side must be the same as this side, which is radii. Okay, so I'm going to say OL is the same as OL is the same as OQ. Reason radii. And if that is true, then I have an isosceles triangle. So if this is X, then this must also be X. L is it 3 and 4. So which means I'm going to get 180 minus 64. 180 minus 64. It's fine. Let me just do it. Let me use that approach. So I'm saying OLQ. OLQ must be the same as Q1. Reason, angles opposite sides. Then which means if I have twice of Q1 plus 64 must give me 180 because of angles in triangle LOQ. I can move the 64 that side. Twice Q1 is going to be 180 minus 64, okay, which is 116. And then I'll divide both sides by 2, which means my Q1 is going to be 5.8. Okay, so guys, that's how I would have obtained that angle. Alternatively, when you look at Q1 is exterior to the triangle LMQ. So one can first of all tell us that the angle L5 is a 32 because of the tan chord. Yeah, we must use the tan chord somewhere. If this is a 32, then Q1 must be 32 plus the 26, which must also give us 48 degrees. Reason, exterior angle, triangle LMQ. As this would have been the shortest way, but nevertheless, still have the same answer. So use whichever format you use. Okay, guys, that is question number 5.1. No, that's 5.1. Let's move on to 5.2. They are telling us that in the drawing, in the diagram below, A, B, C, and D are lying on the circumference of the circle. Can we prove that C2 is the same as B minus A1? This is serious now. C2 is the same as that minus that. Okay, let me do this. I'm going to start by letting, what can I let? I can let my D1 to be X. Okay, if I call that X. And then I'm gonna let my A1 be a Y. Okay, so that is a Y. Then what I know is that ABCD is a cyclic quadrilateral, okay? Which means that B is gonna be the same as X. Reason? Because of exterior angle of a cyclic quadrilateral, ABCD. Okay, so calling this X. This and the same as that. Then if that is true, I can try to find D2. D2 is gonna be 180 minus X. Either angles on the line or opposite angles of the cyclic chord. Okay. Then from there, I could go on and try to find what my C2 is from triangle. So I'll say that from triangle ACD, if I have C2 plus my Y plus my D2, which is 180 minus X, this must give me 180. And I'm gonna move everything that side and leave C2 on one side. Oh, this one is gonna be angles in triangle ACD. So C2, when I move the 180 that side, it cancels out, move the X that side, it will be just X. And then the Y is gonna be minus Y. Okay. So that is my C2. Then when I look at what is B minus A, I'll say, but B minus A1, what's my B? Say my B was X. Minus our A1, which is a Y. So therefore, C2 is the same as B minus A1. Okay, guys, you could do that. Or alternatively, someone would have used the letters the way they are, D2, A1. I find this much more simpler, much more easy. Guys, you are allowed to do that. Remember, in Euclidean geometry, you're always allowed to construct and add stuff as long as they help you in answering the questions. Okay, that is question number 5. We move on to question number 6. They are telling us that in the diagram below, O is the center. Okay. We have A, P, B, a point in the circumference of the circle, arc AB subtends A or B at the center and APB is at the circumference. Can we use the diagram to prove that A or B is twice? Okay, guys, with this question, you need to do some constructions. Okay. You can just connect this. Okay. And then can label this as 1 and then label this as 2. So we know that P is the same as P1 plus P2. Then what we need to also state is that OP is going to be the same as OA, which is going to be the same as OB. The reason, those are radii of the same circle. And if that is true, which means that this P1 is the same as this angle. Okay, so I'm going to say A is going to be the same as P1. Reason, angles opposite, equal sides, because POA is an isosceles triangle. This is the same as that, same as that. So the same story happens with B, which means B is the same as P2. Angles opposite, equal sides. Wow, okay. So we're calling this a P1, we're calling this a P2. Now, can we go on and find the size of POA, this angle here? So we're saying that POA is going to be the same as 180 minus twice these angles, twice P1. Okay, reason is angles in triangle POA. When you add this P1 and this P1 and then the O, you must get all of that for you to get the O, this one. Then I'll do the same thing on this other side, that POB is going to be the same, 180 minus twice P2, still the same reason. Angles in triangle POB. Then, if I try to find, okay, the entire size of this, it will be as good as me adding up these two. So that I have my, how will I even put it? Okay, so I'll say when I add the two, POA plus POB. Okay, minus 2P1 and then minus 2P2. Just this sum of this. And then for me to get my A or B, okay, A or B is going to be 360 minus whatever I got here. This is 360 minus 2P1 minus 2P2. Reason is going to be, it's a revolution. Or angles at a point. Must add up to 360. So this plus what I got must give me 360. Open that. I'm going to have 360 minus 360 plus, and then a plus. So I'll factor out the two, P1 plus P2. So 360 and 360 will die out, and then I'll be left with twice P1 and P2. And remember what we said in the first statement, that P is the same as P1 plus P2. So therefore, A or B is twice P. But we know that P, and say that A or B is twice APB. Just leave it like that. So guys, that's how the proof could be done. Okay. There could be other simpler ways of doing it, but this is what I feel comfortable with. Then 6.2. In the diagram below, F is the center, okay, of the center, and AC is the diameter, right? AC is produced to K such that B1 and B2 is 122 and K is 26. All right. Can we show that BK is a tangent? So for us to show that BK is a tangent, number one, we don't have any radius around. We need to apply the term chord form. So if I can prove that B2 is the same as A, then that is enough for me to make this BK a tangent. So what I can start with, I'll have to find the size of what? I can start with B1. I don't know, whichever way you want to start. So I'll say B1 is a 90. Remember, AC is the diameter. So the angle that is in the opposite end, the diameter will be 90 degrees. Reason, we are saying angle in a semicircle. Okay, so if this is a 90, then what is our B2? B2 is going to be 122 minus 90. So B2 is a 32 degree complementary angles. Not complementary as such, but the remaining part. So we're saying this is a 32. Then I can say that from triangle, which triangle? ABK. From triangle ABK, I can look for the missing angle A using the angles in the triangle. So what I'm saying is I'm I'll have A plus 122 plus the 26. You must give me 180 degrees. Angles in triangle ABK. Okay, so if that is true, then my A is going to be 180 minus. Remember, I'm looking at this entire angle. I'm looking at this entire angle. So this triangle is what I'm focusing on. So what is 122? That's going to be 148. So 180 minus 148, I'm getting a 32 perfect. So remember what we said, if A is the same as this B2, then it's a term chord. So therefore, BK is a tangent. We can say since A is the same as B2, which is equal to 32, therefore BK is a tangent. And the reason is going to be the converse of the term chord. Or you can just tell us the term chord. Converse of the term chord. Okay, that is question number 6. Question number 7. Telling us in the diagram on triangle ABC below, D here points on ABs respectively such that D is parallel. Okay, can we prove the theorem that states that AD over BB same as that over that? So still, even in this question, guys, we need to do some bit of construction. Okay, so you can always extend this so that it's a perpendicular. You construct this so that that is also perpendicular. And then you also have to draw lines to connect B and E. Then you also need to connect C and D. Now, after doing that, we can label this to be a K and then this to be H. The height H and then the height K. Then what I can do is that I can find the ratio of the area of ADE over the area of DEB. Okay, we know that area is normally given as a half. My base is going to be the AD. Okay, so we're talking about ADE. Okay, so I'm focusing on this height, which is K. And then DEB. So the same triangle having the same height. So it's going to be a half. I'm going to take this to be my base, which is DB, but with the same height, which is K. So the K and the K will cancel, a half and a half will cancel, which means AD is going to be DB. So the rest is AD over DB. Then I'll move on and talk about the area of ADE. Okay, divided by the area of DEC. Talking about ADE again, but this time around we're talking about DEC this side. So I'm saying a half, instead of using the AD, I'm going to focus on the AE. AE times my height in this case, which is H. Over half, in this case, the same height H, but with the distance EC. So EC times H. H cancels, a half cancels. So I have AE over BC. But one thing we know is that the area of DEB is the same as the area of DEC. Let me just highlight this separately. Okay, so it's saying the area of DEB. Okay, the area here must be the same as DEC. The area of this side. That's what we say. So which means if we get the area of ADE over the area of DEB initially, ADE, DE must give us the same ratios as area of ADE over the area of DEC. Okay, then I can just equate the two ratios. So AD over DB is equal to AE over EC. So guys, that's what they wanted us to prove. So what we mark usually will be the constructions you make, the labeling, and how you break that down. 7.2. In the triangle DXZ, AC is parallel to this, BP is parallel to that, and it's drawn the intersect AC at B. Okay. Can you prove that BC over YZ is the same as DA over that? So when I look at this, I have quite a lot of triangles. I have this triangle that I can use. I have the big triangle that I can also focus on. But I also have this triangle in this sort of format, in the first kind of format. Okay. So what I'm gonna say is that from triangle DXY, okay, from triangle DXY, DX, and then Y. This is our focus. DXY. So what are we saying? We're saying that AD, okay, if we get the AD over the DX must be the same, let's cut to X, must be the same as DB over the DY. The reason is going to be proportionality theorem, because AC is parallel to XZ. Proportionality theorem because of that, okay? Then if that is true, then I can look for another triangle, which is DYZ, the one that I was looking at initially. So from that triangle DYZ, I can see that BY, what should I use? Okay, it's fine. Just use BY, no problem. You can see that BY over my BD. Does it make sense? BY over BD. No, it's not going to make sense for me. Let me look at it that way. Maybe come that side, but let me just focus on this where I have my YZ. Okay, so this divided by my P. Let me switch it around and say that my PZ over my YZ is going to be the same as, since I've used PZ, then I'm going to use BD over this whole distance, which is dy. Okay, it's going to be the same reason, proportionality theorem, because which lines? PB is parallel to DZ. Okay, and I need to compare this and this. I have a DB, I have a DY. I have a BD, I have a DY. So which means my AD over my DX is equal to, so I'm equating this with this, the same PZ over YZ. Are we there? So we have a BC over YZ. We have a PZ. Okay. We have DA, we have X. Okay. So these other parts are fine. Let's now focus on the PZ and BC. So how does PZ and BC relate? So PZ is here. This is a BC. Now, one thing we need to remember from our quadrilaterals, let it be a rectangle, let it be a square, let it be a palm, a parallelogram, even a rhombus. Okay? I'm just focusing on shapes where the opposite sides are parallel. Okay, so if this is parallel to that one, this is parallel to that one. In other words, you have two pairs of parallel sides. In most cases, the opposite sides will be equal. Okay. So we can call this a parallelogram, or we can refer to it as a rhombus. It can be referred to as a rectangle because the opposite sides are equal. So we can say that since PZ is parallel to BC, and then PB is parallel to CZ, which means PZ is equal to BC. Hence, our BC over YZ must be equal to AD, and DA is the same thing. Is equal to DA over DX. Then we're done with that proof. Okay, then question number 8, the last one, final. Okay, so in the diagram below, NPQR is a cyclic quadrilateral. Okay, with S that is drawn, it's not a center, but it's on the chord PR. N and S are joined. Okay, R and S is the same as P and Q, which is equal to X. 8.1. They want us to prove that NSR is the same as NPQ. This is NSR. Then we need to choose the NPQ. It's a different NPQ. This is N and Q, something like that. Can we find any similarities in this? So what we can see is that there's X there and then there's X. So I'm gonna say that P and Q is the same as R and S. Okay, P and Q. So this angle is the same as R and S, which is X. And the reason is given, it's given to us. They told us that that's X and that is also X. Then, what else do I see? Which other angles? When I look at R1 and Q1, sorry, Q2. Okay. When I look at this, I can see that this is going to be the same as that. So say Q2 is the same as R1. Reason, angles in the same segment. Okay, angles in the same segment. And then automatically we can say that P is the same as S1. And then that is remaining angles of the triangle. So now we have three facts. Remember, these three lines represent, or they represent similarity. And for similarity, normally look at the angles of the sides being in proportion. But in normal cases of the 12, it's normally the angles that we look. So we're gonna say, therefore, NSR is similar to NPQ. because we looked at the angles. So angle, angle, angle. Some people would prefer to use the triple A, no problem. So 8.1 has been taken out. Let's look at 8.2. 8.2, they're asking us to prove that NQR, do I have enough colors? Let me use it blue. NQR, this triangle. That triangle is similar to another triangle. Let's go for green. NPS. We need to find what is common between these two triangles. Okay. Now, what I can see, let me just do it again. So I need to look for what is common there. One thing we know, P1 is going to be the same as Q1 because of the same segment. Okay, so that's what I'm going to start with. P1 is the same as Q1, angles, same segment. Okay, those segments subtend equal angles, something like that. So P1 is done with Q1. Then what can I see? When I look at this angle here, there's X and then there's N1 for this small triangle. Okay. And then when I look at this angle, I can also see the same thing. So I'm going to say that R and Q is the same as S and P. Okay, because both of them are having X plus N1. You can say given, no problem, because it's already there in the drawing. Then automatically, for as long as we have that, which means the whole of R, that is R1 plus R2, is going to be the same as S2. The reason is going to be remaining angle, the triangle, remaining angles of the triangle. So we have our three effects. Then we can draw the conclusion that therefore triangle NQR is similar to triangle NPS. Angle, angle, and angle. So guys, that is the end of that paper, 130 marks. Good luck as we wait for our results now. Thank you very much. Let's meet in the next. The owner of the small company wishes to establish whether advertising in a regional newspaper is effective. Does it bear results? Okay. The table below shows the amount that was spent on advertising and the sales for the last 9 years. So the first year, the second, the third, and so on and so forth. So this is how much was spent on advertising. And then these are the sales, like the outcomes of the advertising after the advertising was done. Okay. So usually the amounts or the values in the top row will always represent the X. In this case, that told us those are the X values, and then these are the Y values as well. Then 1.1.1, they're telling us to determine the equation of the least square regression line. Okay, So one thing we need to know that for the regression line, it's usually in the form of y is equal to a plus bx. Some calculators will show you these capital A's and the capital B's. And so what we need to do, we need to set our calculators into the mod function. From mod, we need to look at start. And then from start, we need to choose the regression line, which is the a plus bx. If it's not there, then you have to choose the regression equation. Then you're gonna get two columns that are having x and y, and sometimes even the frequency can be indicated. Don't worry about the frequency. So for the case of the x, we're gonna enter all the top numbers for the top row. All the numbers must be entered, and then the corresponding y values should also be entered. Once that is done, we must press the AC button, or sometimes call it clear all. If not, you must use the on button and just to clear whatever is on the calculator. Then from that, we're gonna press Shift and 1. And then we choose the relevant item we're looking for. So in that case, we're gonna start by looking for the value of A and then the value of B, and rewrite our equation. Okay, so when I do that, enter my values, X and Y. Okay, I press the clear all button. And then once that is done, you can press the Shift and 1. And then I'm seeing my A as 1730.22. I'm getting a B of 13.96. Okay. So I want to use the answer book. Let's see if I can access it. Okay. So with this answer book, it's more or less the same information for the same table and everything. So we said y must be the same as a plus bx. And we got our a as 1730.22.